Hi and welcome back to DWN Academy, and welcome to this end-to-end project on air quality real-time analytics with Microsoft Fabric. And this is going to be powered by Open Air Quality APIs to bring in the real-time data from different locations to track different pollutants. So we're going to learn about this in this course, and also powered by different real-time intelligence components such as Eventstream Eventhouse within Microsoft Fabric. And if you're new to Microsoft Fabric, this is an advanced course, so we assume you have some foundational knowledge on Fabric, such as capacities, one lake, and other information. And if you're a beginner watching this video, so please go through the free course we already have on the platform. So that covers the foundational concepts, and then you can jump onto this advanced project. Okay, so with that, let us get started. And a bit of introduction about me. I'm Sheikh Mohammed, Microsoft Certified Cloud Data Architect and founder and CEO of DWN Academy, and Microsoft Certified Trainer, active trainer with close to 15 plus years of IT industry experience. And I've already trained close to 500 plus students across India, Europe, and other key locations across the world. And I'm an expert in Microsoft Fabric, Azure, Power BI, and whatnot, real-time data modeling as well. Okay. And at DWN Academy, our core mission is to turn curious learners like you into confident professionals through structured real-world learning. So whatever content we produce in Academy, it is around hands-on and real-world application as well. So all the end-to-end projects we have built so far in the Academy covers real-world data and probably fits into a domain like healthcare and all. We leverage dummy data due to privacy reasons. Otherwise, we explored real-time APIs, open APIs available out there to build the end-to-end solution so that learners get that confidence to try and implement when they get deployed into projects. Okay, so let's get started. So why air quality real-time analytics and why it matters in today's world, right? So, I think air quality matters a lot due to rising health risks, due to urban pollution, a lot due to industry pollutions and other aspects as well. So there are underlying health risks involved due to urban pollution, and I think there is a need at the moment for real-time environmental monitoring. So you may have different government websites helping you to track the air quality, but I thought let us build the end-to-end solution in Fabric so that we can bring in the open air quality API data, probably with the demo of probably one location, so that you can extend it to different locations, and then you can build your own dashboard and then track the air quality in near real time. And also, I think with data activated capability, we can put some alerts if there are rising levels of air quality index. And there are different pollutants. We will quickly go through and understand those pollutants so that when you follow along this project, we'll have some idea about different pollutants and how we can derive some insights out of your dashboards. Okay. And I think traditional systems are kind of fragmented and not scalable. So I wanted to build this project end-to-end in Fabric so that you get that feel of real-time project within the Fabric. And I think at this moment, the real-time use cases are critical, I would say, and you need to leverage all of the components available in Fabric to build your real-time solution and be ready to be deployable for customers. Okay, so with that, I think let us jump on to our solution, real-time analytics solution that we are going to build in this course step by step. So be with me. So at the end of this course, you will have deployable solution, okay, tracking dashboards where you can track the real-time air quality APIs in near real time. Okay, so almost on daily basis we are going to ingest the real-time air quality index data from OpenAQ APIs, and then we are going to monitor it, and then we can put on some alerts, and we are going to build the solution and automate this solution completely end to end. Okay. So it's end-to-end pipeline using Microsoft Fabric components. So we're going to see step by step how we can do that. And we're going to ingest live data from OpenAQ API. Maybe for some locations you may not have the latest data, but I have picked one location in New Mexico in United States, so that we can leverage that live data almost coming in instantly daily, and we can see the data in action in dashboard. Okay, and we're going to look at what that OpenAQ API is and how we can set up your own API keys and bring the data in. So everything will be covered in this course. We're going to provide real-time dashboards and AQI insights, air quality insights, right? So probably you're free to choose different locations and then bring in, but the concept that I'm going to teach for one location, you can extend it to different locations and still apply the solution to different locations, and then you can build your own dashboards as well. So it is not necessarily you need to stick to what I'm kind of demoing with one location. So you can explore different locations, and I'm going to introduce you to the API so that you can build your own dashboard when you follow along this course. Okay, so I hope that makes sense. So in the next video we'll quickly look at the architecture diagram to see how the data flows from OpenAQ API through different medallion layers. We are going to build the bronze, silver and gold layers, and we are going to look at the grain of fact table, and then we are going to build the semantic model, and then finally reports and dashboards. So we'll walk through the architecture quickly in the next video. Okay, so in this video I'm going to quickly take you through the architecture diagram for our air quality real-time analytics solution. So let us quickly run through the data flow so that you can get to know how data flows from API into different medallion layers, and then into the semantic model, and then how we are building the reports as well. Okay, so as I mentioned, our data source is going to be the OpenAQ APIs. So it is open air quality API. So we are going to look at that API and see how we can get the API keys so that you can build your own solution by leveraging the APIs, different APIs available to bring in the data, not only for the measurements, the pollutant measurements, but you can also bring in other metadata as well that we're going to look at. So it is not kind of a single APIs. You have a lot of OpenAQ APIs available to bring in the location data, metadata, sensor metadata, and then the actual measurements itself. So I think we are going to leverage kind of 3 APIs probably. To the latest will bring in the sensor measurements from the actual locations deployed, so that you can look at the data that is available on daily basis, okay, for different pollutants like let's say PM₂.₅, PM₁₀. So if you're completely new to those pollutant types, probably I'll give you a bit of introduction in the next video so that you can be aware of different pollutants. So, and also, as I said, we can also bring in some metadata for location sensors, and we are going to leverage those APIs as well within the OpenAQ. Okay, so that's how we are going to look at. And I think the data is going to flow into Eventstream and into the Eventhouse. See, Eventstream is going to be the gateway, you can say, the data ingestion gateway to stream the data into the KQLDBs within the Eventhouse. Okay, so that is going to be our entry point or a gateway that you can think of. And I think for each and every API, we are going to build different or one event stream for one API to automate it, and then have that endpoint ready to stream the data in near real time or real time into the databases. Okay, so that's the idea. And I think inside our data landing zone is going to be KQLDB within the Eventhouse. So we're going to quickly talk about why Eventstream and Eventhouse, because since we are looking at a real-time use case, so it is ideal to choose the capabilities such as Eventstream for streaming data, and then the Eventhouse with KQLDB. So it is a perfect solution for real-time use cases. And I think if you're new to KQL, no problem. So probably we can quickly look at the basics of KQL when we do some querying with KQL within the KQL DB. But why KQL DB? It is perfectly optimized for real-time use cases and real-time capabilities. Okay, so Microsoft have introduced this solution KQL, Custom Query Language, and it is optimized well enough to handle your real-time data. And if you want to do some real-time querying of your data, that's when KQL is much efficient, I would say. Okay, so we'll talk about in the later videos probably the KQL basics, how the syntax is different from SQL, and then probably we can move on with the querying part. Okay, but we are building this bronze, silver and fact layer, the gold layer. So we are going to follow that medallion architectural pattern, and I hope most of you are already aware about medallion architectural pattern. So we are going to flow the data through bronze layer, silver layer and the gold layer, which means like the raw data is going to be ingested, the streaming data is going to be landed in our bronze layer for different locations if you're exploring, and then we are going to do some transformations and then load the data into our silver layer, and then we will build our fact table, which is our gold curated data. So we are going to talk about the grain at which we store the data into fact sensor daily table. And on top of that, we are going to build some calculated measures on top of this. So we are going to store that or persist that in another table, which is fact sensor calculation. So the data flows through different layers, and then it will be curated and stored in the fact layer. And the grain is going to be at the daily level for the sensor, as we named it, it is going to be fact sensor daily. So it is going to be at a daily grain for every pollutant, you can say, per location. So for example, if you have let's say 10 pollutant categories for a particular location, then you're going to ingest 10 different records, one record for each pollutant in that location into the fact table. So we are going to look at the grain in detail when we move on to the transformation part, or when we get into detail on those things. Okay, and we are going to build some dimension tables right within the KQL DB, so that we can build our semantic model by connecting to Eventhouse from Power BI, and then we can build those relationships between fact and dimensions and then deploy our semantic model. Okay, but the solution is simple. We are going to have this event stream gateway, and then we flow the data through different medallion layers and then prepare our fact layer, and then dimension tables will be loaded with the metadata APIs, as I mentioned, let's say location metadata APIs, and then we will build our semantic model, and then we'll be ready for our reporting and dashboarding. Okay, so we will talk about, I think it is going to be mostly the Spark, PySpark notebooks that we will build to push the data or flush the data into Eventstream Kafka topics. We are going to learn about different protocols in Eventstream, and I think which protocol we leveraged, which it's Kafka, and how are we going to push the data into Kafka topic, and how it is streaming the data into bronze layer, and the different PySpark notebooks that we are going to leverage during this course to see how we can transform the data and then load the fact table. And we are also going to leverage KQL scripts. Okay, similar to SQL scripts, we are going to write KQL scripts to transform our data. And I think we are going for the fact loading also, we are going to leverage KQL scripts. So you can get a good understanding on KQL scripts, and probably by the end of this course you will have good knowledge on how you can write some KQL queries in case if you are leveraging real-time use cases for your customers. Okay, so that's a bit about the architecture that we are going to build in this course to leverage the OpenAQ APIs and different streaming components in Fabric to derive some real-time air quality insights. Okay, so out of the OpenAQ APIs. So let us dive into the project. So with a few prerequisites, in the next video we will wrap up the introduction module, and then we will jump on to the next wherein we will try and set up the event stream for data ingestion into our landing zone, which is bronze layer inside the KQL DB. Okay, so with that, we wrap up this video, and I'll see you in the next one. Well, I just wanted to quickly set some expectations in this video. You can say learners' expectations for this particular course before we jump on to the data ingestion part and looking at the OpenAQ APIs and further deep into it. So, as a learner, you should have foundational knowledge into Fabric. If you're completely a beginner into Fabric, I would recommend you to watch some of my other course, the DP600 foundational course with COVID dataset. That covers extensively the foundational concepts such as one lake, capacity, and warehouse, lakehouse. You need to understand what are the different components that are available or different experiences that are available within Fabric. Then I think it will be a good starting point for you to jump on to advanced courses like this, because this course, end-to-end course, purely focuses on real-time intelligence components in Fabric like Eventstream, Eventhouse, KQL. I think that is something advanced, probably people with intermediate or some knowledge into Fabric or into data world can relate, and then they can quickly grab things. But if you're completely new to SQL, then I think it's difficult for you to pick up KQL, which we are going to build in this course for our real-time use case. But I would recommend you to go through some Python basics, SQL basics, and Fabric components, understand those, and then come back to this course, and then you can you're ready to go, I would say. So those are some of the expectations I wanted to set even before we jump on to the course content itself. And I hope that's clear. If you have any questions, or if you need my support, if you're a complete beginner, feel free to reach out to me in LinkedIn, or you can comment below in the same lesson so that I can reach out. My team will reach out to you back, right? So, but this solution is going to be a real-time analytics solution, and it is going to be end-to-end, completely automated, real-time use case. Okay, so we are going to ingest live data from OpenAQ API, and if you're a complete beginner, you might struggle to understand. You might be able to build it, but you need to understand the fundamental concepts. Without understanding all of those fundamental concepts, it's really hard for you to grab things and then move along in this course. So I hope that's clear, and I'll see you in the next one. Hi, and welcome back. So in this video, I just want to quickly show you the OpenAQ API that we were talking about during the architectural walkthrough. And I think we will quickly look at the documentation for that API and what are the different APIs that you can call and then bring in the data for the sensor readings as well as the metadata as well. So I think basically we are going to leverage, probably from demo perspective, couple of APIs, but you can explore other APIs as well if you're interested to bring in more metadata and stuff like that. So basically, as a part of data source and preparation for data ingestion in the upcoming videos, so we're going to leverage the locations API, and we will pass the location ID, and I'm going to show you exactly for demo purposes what is that location that we are picking for demo, right, to bring in the sensor metadata. And I think it's basically one of the location from US, New Mexico. I have picked it because that location is bringing real-time data almost on daily basis. But I think few locations I tried in India and other locations, which kind of seems outdated to me, so the data is not coming up to date. So I think you can leverage some other locations as well, and feel free to explore other locations and try and identify if there are locations that you are interested in to bring in the metadata. So again, just to highlight, it is not necessarily you need to follow through only with the location that I'm kind of exploring and showing you as part of demo purposes. You feel free to bring in more locations and then build your solution as you want. Okay, but the concept and the components that we're going to use remains same. And from OpenAQ APIs, you can bring in different locations, and then you can start building your own dashboard for monitoring purposes. Okay, so you need not necessarily follow what I'm going to show you. You can bring in more data as well, and for more locations as well. Okay, that's something I wanted to highlight. And I think we are also going to leverage some metadata APIs, like to bring in the sensor metadata and location metadata as well. Okay, I think this location slash the location ID slash latest brings in the real-time values, and the location ID will bring the metadata for the location and sensor. So we're going to look at the samples in this video to see some of the JSON samples. We can look at it, and we can see how we can call those APIs to bring in the real-time data to track the air quality. Okay, so let's quickly jump on to the the documentation portal for OpenAQ. So this is the OpenAQ, if you're not aware. So this is an open kind of documentation which you can bring in the air quality data from across the world, from different locations. So from the sensors that is placed across different locations, okay, by different providers. There are different providers who have placed sensors to read the air quality data, right? So, but OpenAQ providing this for completely free, so that you can leverage, anyone on this planet can leverage this API to kind of do some research around the air quality and make the planet better, right? So that's why I think OpenAQ appreciate OpenAQ for providing this for free to leverage the APIs to bring in the real-time air quality data, okay, for study purposes, right? You can go through, I'll share the link in this video lesson right below. You can click on the link, go through the documentation, go through the API documentation as well. But let me take you through the API documentation real quickly, right? So let me get started. So this is the documentation. You can read about the API. It provides open access to global air quality data, okay, and I think they're already capturing quite a lot of pollutants. Okay, so I think maybe we will also quickly talk about in the next video what are the different pollutants, maybe a quick introduction to understand what are the different pollutants. But you don't want to go into detail, probably we can cover in the same video, but I think you can Google out and understand, what are the different pollutant types that we are looking at, right? So you need not go into detail, but at a high level, you can try and understand what are these air pollutants, right? So it says that OpenAQ focuses on air pollutants, primarily aggregating these 2.5, PM, PM10, and SO2, NO2, CO, O3. So don't focus too much on all of the pollutants. Maybe for demonstration purposes, I'm going to look at these two. So it is particulate matter, and I think it is 2.5 measured in some units. We will go through that, but this is more dangerous. If there are some levels, target levels, we will look at the standards set globally, and if you're breaching that, I think that is more dangerous to inhale, and then that will cause respiratory issues and lung issues, and it will be like even life-threatening as well, right? So that's why I think government organizations and even a lot of organizations are carefully monitoring these levels across the globe, and I think every government, every country's government, also keeping a tap on these levels, okay? But PM10, I think you can read more about it. I'm not going to get into the details of it, but the basics of it, it's particulate matter. I think the amount of, you can say in simple layman terms, kind of, if you just Google out what is PM2.5, okay, and I'm not going to get into depth of it. So you can just Google out and learn more about it. So 2.5 micrometers, less in diameter, right? Those are fine particles. If you compare these two, PM2.5 and PM10, I think 2.5 is more dangerous because that is going to be finer particles than PM10, which is 10 micrometers, compared to this. So these are fine particles, a major component of air pollution, can pose serious health risks when inhaled, right? So you can, if you're interested, you can learn more about these pollutant types, even different pollutant types. But the idea is we are going to bring in data, look at these different pollutant types, maybe focus on a couple of pollutant types to track and monitor probably for one location, so that you can extend the solution to different locations and different parameters or pollutant types, and then leverage and build from there. Okay, so that's the idea. Okay, so probably let me show you a couple of API documentation. So under resources on the left side, you can see there are quite a lot of APIs. Okay, so we are going to leverage this latest, as I mentioned. The latest API is something provides you with the most recent air quality measurement. So we talked about the pollutant types, right? So it brings in the latest measurements for those different pollutant types from the sensor readings for that particular location. Okay, so if the data is available up to date. So each record provides the measurement time, value, location, coordinates, and sensor information. Okay, even with the coordinates information, it is really helpful to tag that in a map visual to kind of track or monitor real time across the globe. You know, we can put a visual on map with the coordinates that we are getting in. Okay, the latest is we can quickly look at some of samples. You know, how are we going to call this API? So the call is going to be like this, either or this, right? So it is api.openaq.org. it's version 3, location / this is the ID. And I think if you wanted to know probably what's this ID for different locations, maybe we'll come to that. But here they have provided you a sample, the sample payload. We can look at it. So, but the location ID / latest will bring you the latest measurements for that particular location. So that's the idea. Okay. So key fields, you can read more about the key fields. You know, date, time, value, coordinates, value, the actual sensor reading, then sensor ID information, locations ID. So I think this API will bring the sensor ID and location ID, but if you need to know what those, if you need to know more about those information, the metadata for sensor and locations, that's when you need to try and bring in other APIs, metadata APIs, to kind of perform the join, let's say, and try and understand what those sensors are. Otherwise, you know, you'll not be able to understand what those measurements are by looking at sensor ID and location ID. Okay, but location ID, yes, we already came to know. Maybe, you know, with the sample response payload, we come to know. Maybe you can take the same 2178 also, you know, if it's because I think for our demo purposes we are taking in 2178 as shown in the OpenAQ example payload. Okay, I think it's easier, you know, if you want to leverage other locations, definitely you can bring in kind of call the locations API and kind of iterate through and understand different locations to explore more locations around the world. Okay, so that's the idea. So if you just quickly look at the load, I think response payload, so this is the API call and it returns something like this in JSON format. Okay, the results set holds the information, the UTC and the local time, and then you can see the value for that particular sensor ID 3916. So you may not be aware at this point what this is, so you need to call I think the other metadata API to understand what that sensor ID is. So we are going to look at that as well. And I think the location ID is already known, and what that location is, so we will also come to know. I think you will not be able to understand what that location is as well. Okay, I think that's when location API will help you to understand more about that location with the ID, and even I think it has sensor information as well. We will quickly look at that. Okay, so it has, all it has is the latest measurement for every single sensor for that particular location. Okay, so you can see different values and coordinates, sensor ID, location ID, and this is the response payload for different pollutant types. You will get the latest measurements. Okay, and if I can scroll over to locations API. Okay, this is location resource or API, provides details about air quality monitoring stations, including their name, geographic coordinates, and time zone information. Let us look at a response payload for this. So all you are going to do is you're going to pass in the location ID. Okay, and then you'll get the required information. So essentially we are looking at the location Del Norte. It's Albuquerque locality and it is in America, Denver. You can see the country ID, code information, other information here. Okay, in the response payload for this particular API. Okay, and you can also see the owner information, provider, who is the provider providing these sensor readings, AirNow, and other information you can see. Is it mobile or monitor? You can see all the information, government monitor, and you can see the sensor information also here, right? So the sensor ID and what that sensor is, okay, and the parameter information, okay, and units information and the display name. So for example, let us look at PM₂.₅ and PM₁, okay, for the sake of demonstration. If you just scroll down, okay, so you can see PM₂.₅. Its ID is 3920, okay, and it's measured in micrograms slash kind of cubic meter, you can say, right? So that's how it's measured, right? And I think PM₁ is also here, which is 3919. So now you can relate those sensor IDs with the latest API information, right? So if you can just scroll down, if you want to look at the PM₂.₅ for that particular location, which is in Denver, you can scroll to, I think 3920 is what we looked at for the PM₂.₅, right? So you can see sensor ID 3920 and the value is 4.4 as of kind of, I think this is not the latest response what we are looking at. Just for the sample, they have provided the response payload to understand more about the sample response, okay, but you'll get all the information and the sensor ID and the value itself. So I think we looked at two APIs so far. The latest brings in the sensor measurements and locations, help us to get the metadata for the location as well as the sensor, okay, but you can also feel free to leverage all the other APIs like countries, instruments. There are many APIs. They're providing parameters, owners and manufacturers, sensors, but I think for the sake of demonstration I'm going to stick to a couple of APIs to keep it simple, to try and not to make it more complex, but you can definitely leverage all of these APIs and see if you can bring in other metadata into your solution and then build as we go along in this course, okay. So with that, I think we will wrap up this video, and I think in the next video I think we will try and probably in a sample work notebook, PySpark notebook, we can try and call these APIs and understand how the responses are being fetched from the APIs, and then we can jump on to Eventstream configuration for the real-time data ingestion, okay. So thank you for watching, and I'll see you in the next one. Hi and welcome back. So in this video I just wanted to quickly help you to set up the API key, because you need to set up the API key, and then you need to have the API key stored in a secure place so that you can call the APIs, different APIs we just quickly had a look, and then pass the API key in the header. Then you will get the required response, and then you can work through the response, and then you can take your data to your raw tables in Eventhouse. So before we jump on to data ingestion, so we need to quickly look at how you can set up the API keys in OpenAQ environment, right? So I think I'll share the link in the lesson video below so that you can navigate, and then you can start setting up the API key yourself, right? So here I think come back to OpenAQ, and I think you can quickly just let me search for OpenAQ instead of the documentation. So just get into openaq.org, right, and then you can read more about the data and other information here. And I think if you need to, okay, so set up one for you. So go to explore the data, so click on explore. Okay, so I'll share the exact link in the lesson so that you can navigate to this URL correctly. Okay, so under explore you will have the option to sign up and then log in as well as donate. So here you can see the global map, and then the different kind of data points that you can see. I think you can always have a look at different pollutants. We talked about a couple of pollutants, so you can have a look at the pollutant, let's say PM₂.₅, and probably you can choose different locations and have a look at the data point, right? So you can always just, if you click on a particular data point, it will help you to understand the measure. So we are looking at Bahrain at the moment, and you can see the sources are now and the latest readings in the last 24 hours. So no recent measurements as we can see, but if you just zoom out and then probably if you try and look at, you can look at any different location, and then try and see if I can look at the AQI indexes for Dubai. Let's say Dubai Motor City, we have other locations inside Dubai, and you can see we have the measurements. For PM10 we don't have any recent measurements, but the last 24 hours we have other readings captured, and you can see the information there. And if you click on show details, it will take you to more information. You can always explore this OpenAQ air quality index across the world. Okay, so to set up the API key, you can navigate to sign up on the top right, and then you can start creating your own account. You can give some basic details like name, address, then create the password and get started. So I think you will get probably a one-time code or something like that, and then you are done. Then you will once you log in, you should be able to see your API key available. Okay, so set the account up, and then you get the API key, store it somewhere safely, so that at the time of development, or when we are trying to ingest the data from API key, APIs, different APIs like countries, locations, or the latest measurements, you should pass the API key in the header in your request to get the required response. So I think that's a wrap for this video. So it's all about setting up the API key. So I hope by this point you have created the API key, and I'll see you in the next video. Hi and welcome back. So in this video we will get started with the data ingestion. So we are going to talk about how are we going to ingest the real-time data from OpenAQ APIs into the landing zone, which is the KQL database in Eventhouse. And I think if you're completely new to these components, if you're hearing this for the first time, Eventstream or Eventhouse, I'll quickly give you a brief, but if you want to learn more about it, I can share some documentation links. You can read more through about it, right? And I think like SQL, we are going to look at KQL, Custom Query Language. And if you want to learn about basics, so I do have already produced videos around KQL basics, so I can probably share those links, lesson links in the same video below, so that you can go through some of the documentation and practice some KQL basics and then be ready, right? Okay, so I think Eventstream and Eventhouse, Eventstream is the gateway, you can say. So these are the components Microsoft built inside Fabric purely for real-time intelligence capabilities. Okay, so it comes under real-time intelligence components, and I think when you want to stream your data into your let's say Lakehouse or Eventhouse, I think Eventhouse is ideal because the KQL experience and Eventhouse is much efficient for real-time use cases. Okay, so you can read more about it. I can share some documentation around that, but we're not going to talk about the fundamentals of Eventstream and Eventhouse, as I already mentioned during the start of this course. This is going to be an advanced course. I assume you have some bit of knowledge about KQL, Eventstream and Eventhouse. So if you're completely new, so I can share some link. As I mentioned, you can go through that and get some basics around KQL and read more about Eventstream and Eventhouse. And I think our real-time pipeline that we're going to build shortly and then load the data into our bronze layer, we're going to build the pipeline with Eventstream, which is our data gateway, you can say. And I think we have different protocols inside Eventstream like Kafka and Azure Event Hub, then the messaging protocol and all. But I think we are going to focus on Kafka, and I think we're going to see how we can set up the Kafka endpoints and how we can ingest your real-time data from OpenAQ APIs into the landing zone, which is KQL database. Okay, and also I assume you have some bit of knowledge about Kafka, because this session is not meant to give you the basics of what Kafka is. Kafka is the streaming platform, again meant for real-time use cases. If you want to stream your IoT data or real-time data, Kafka is it is built by Apache again. The team who built Spark also built Kafka for real-time use cases. And I think you should know some basics like producer, consumer, and what topic is, and all those information. Okay, but we're going to do the Kafka topic ingestion and then the JSON payload for per sensor reading. How are we going to push the payloads when we get the data in JSON format? And I think we are going to work in a notebook, PySpark notebook, and then we are also going to see how we can schedule it and then automate this ingestion process. So that's what we are going to look at in this video quickly inside Fabric, how you can create those event stream and then do the required setup and then build that pipeline data gateway for your data to land from OpenAQ APIs into the Eventhouse KQL database. Okay, so let us quickly move on to Fabric. So here I am inside my Fabric portal. So if I can quickly move on to the workspace, which is Air Quality Real-Time Analytics. Okay, and I think I already built all of the items. I'm not going to show you the configuration from the scratch, but I'm going to tell you what exactly you need to do. Then it will be really helpful for you to follow along and then try and implement the event stream gateways and then the event house and stuff like that. Okay, so I think I'm looking at 3 different event streams. Okay, so before you even hit on create a new item, when all you need to do is go and create a new item, and you can see there are a lot of components available, and the first thing which you're going to create is event stream. So to capture and transform and route your real-time events streams to your various destinations with no code experience. It's kind of ADF kind of experience. You can drag and drop the transformations, and then you can configure the destination where you want to land your data and stuff like that. Okay, but once you hit on create, you can name your event stream, and then once you create the event, hit on create, let's say, the key thing you need to understand to make it operational. So let me create a test event stream, let's say test ES, then hit on create. Just to show you, we have our event streams already operational, but I just wanted to help you to get the setup right. So once you create the event stream, you will get the dialog something like this. Okay, so you can use your sample data, connect data sources, or you can use custom endpoint. So as a part of our demonstration or project, you need to say custom endpoint, use custom endpoint, and then you can name your source, and then probably for now you can leave this preview. If you want, you can activate, but leave it to default, and then click on add, and there you can see I have a predefined template, something like this, the endpoint source and the stream, and then I can go ahead and configure the destination, right? Okay, so once you create the event stream, the first thing you need to do is you need to go ahead and capture some of the Kafka endpoint information so that you can save it somewhere and then use it later in your PySpark notebook, so that you can push or kind of flush your data, your payload into the Kafka topic. So I think I'm going to show you exactly how you can do that. But to make it work, I think what you need to do is on the top right, it is in edit mode. You can switch it to live mode. We are not publishing anything yet. Just switch it to live mode, and then it brings up some information, the protocol information for the endpoint that you have in your event stream, right? So here you can see different protocols like Event Hub, AMQP, which is for messaging protocols, and then the Kafka. So you can click on Kafka, and then you can see the basic information, your endpoint and whether it is active or not. And you have intra ID authentication related information and SAS key authentication. So I think you can move on to SAS key authentication, and then you can capture some of the details and try and store it somewhere. So I'll tell you what exactly you need to capture, and then we can come to the working operational pipeline. So I can show you how I configured the information and how it is operational to ingest our real-time data from OpenAQ APIs into the destination. Okay, so with that, let us move on to the operational event stream that we have built for different API resources that we are going to bring data. So we will quickly look at that. But from Kafka standpoint, so I assume you have some basic knowledge about Kafka. If not, go read and more about Kafka as a streaming platform, and how are we going to configure this. Before we even configure this, you must know some basic concepts on producer, consumer, then topic information. So some basics, if you can go through, that will really help. So, and I think what are the information that you need to capture, so that I will quickly show you. So this is our test event stream that we have just created for demonstration. But I'm going to switch on to the operational event stream in quite a bit. So let us move on to the workspace, air quality real-time analytics. And I have 3 different event streams. I'm going to show you one by one why we have created 3 different event streams. So let us look at this sensor data, right? So OpenAQ event stream sensor data. So let it be, okay. So here you can see this is already an active pipeline that I've built. So I'll tell you how we can configure in the notebooks the Kafka information. So with respect to the endpoint itself, once you set up the endpoint, you need to copy the required information, the SAS key authentication information somewhere. So what are the information that you need to copy? So you would probably need to copy the bootstrap server information, then the security protocol, SASL mechanism, and then this configuration. So why you need this? So because we are going to ingest the data from API into the Eventhouse KQL database, and to do that you need to do the required Kafka configuration, okay, at the time of ingestion. So you would need all this server information and then the credential information. So probably parallelly I can alongside open and quickly show you the notebook. So let me open this ingest open air quality sensor data notebook. So I'll just quickly show you. So we'll run through the notebook. Before we run through the notebook, we will finish the event stream setup and then we'll come back here. Okay, we'll revisit this notebook, but don't worry about this. But let me show you the configuration part so that you can see here, right? So the producer configuration that we are having the bootstrap server information, security protocol, mechanism, username, and password. So from this configuration that you have seen, JSS configuration, if you copy that, so let me come back again. So it's for Kafka. So when you copy this, you will get the connection string information that you can put it there. So all you have to do is just enable this eye icon for the copy to be enabled, and you can copy this, and then you can probably keep it somewhere safe and then do the required configuration, and also the topic name, right? So topic name is also something you need to copy and keep it somewhere. Okay, so that's on the Kafka configuration parameters that you need to copy and keep it somewhere once your event stream is configured and active. And the next thing which you need to configure, right? So once you have the configuration copied somewhere for the Kafka, so you need to configure the destination now. So I think if I can show you the test event stream so that it will be easy for you. So if I can come back here, custom endpoint, I'm adding the source. So I think if I can move back from edit to live mode, so you have the required information for 3 different protocols already in the endpoint, and we are interested in Kafka SAS key authentication, and then we are going to copy the required information somewhere so that we can use it during the configuration in the notebook when we ingest the data itself. Okay, so I hope that's clear. And then the next thing which you need to make sure to configure is the destination, where you want to land your data. So from OpenAQ APIs, right? So that's something we need to quickly configure. So here, I think all you have to do is just click the drop down, and then destinations, you can see quite a lot of destinations, and all you have to do is, let me scroll down a bit, and then you can see there are a lot of resources and then the Eventhouse. So since this is our real-time use case, we are going to land our data into Eventhouse KQL database. So click on Eventhouse, and then you will see data ingestion mode, direct ingestion, or process the event before ingestion. So let it be. So we will leave it to default. We are not going to make any changes on that. So but make sure you have the required setting in place, and then the destination name, which is our you can change the name if you want, and then the workspace is already tagged, and then you need to select the Eventhouse. I already have the Eventhouse created. So at this point, when you're creating the event stream, you need to go back to your workspace and then create the event house and come back here, right? So because you cannot create event house from here. So all you need to do is, if you're not having a working event house, I would say go back to your workspace, add quality real-time analytics, and then create a new item. Okay, so you can just create a new item within the workspace and then create your event house. You can just simply search for event house. I'm searching under favorite, sorry. So all items, event house, there you get, and then you can click on event house and then create one. Okay, so the it is not complex to create, so at the click of a button you can create event house, name it accordingly, maybe OpenAQ_event house, and then keep it ready. Okay, so all you need is the event house creation and then within the workspace and be ready. Then once you have when you come back to your event stream, you need to configure the destination. So since I haven't saved, it keeps resetting in my test event stream, so no problem. Let us quickly add the endpoint and then go ahead and add the event house as your destination, and then you can select the event house once it's created here, and then the KQL database will be automatically created. So when you are creating event house with the same name, KQL database will also be automatically created. You can choose that. And the destination table is something you need to create from here. You know, now I think we are trying to ingest the sensor data, right? So sensor data as a part of this event stream. Okay, so we are going to have 3 different event streams. So to bring in the metadata separately for locations and the other location metadata, right, and sensor metadata. But for the actual sensor readings or measurements, so we're going to build a separate event stream to keep it clean. Okay, so I'm going to show you that. So you can create a new table in the KQL database from within this experience. You can create a new table and name it, let's say, whatever you want to land it. But the one that I've created, you can see I have quite a lot of tables already in my KQL database. So you can name it probably the name of the location that you're going to bring in. So in my example, so I'm going to bring in the data for one particular location to make things simple for this course, but you can always feel free to explore other locations and then you can bring it. So whatever location that you're going to bring the sensor readings, probably you can create name the table accordingly with that location name itself. That's what I did. So this is in New Mexico inside United States. So I've named the location itself as the table name. Okay, so and then you can go ahead and you don't need to change the input data format. It is going to be in JSON format. Okay, and you can, this is by default checked, which means it will activate the ingestion immediately after adding the data source, and then you can click on save. So once you click on save, you will have the configuration saved, and maybe I can show you the operational pipeline. OpenAQ event stream sensor data event stream. So here you can see on the left side I have my sources and destinations already configured and then active. And I think if you switch to edit, you can always look at the you can always edit the information. You can see if I click on the edit in my destination, you can see the destination name, event house, and the table information, everything, right? And if I switch to live mode by clicking live on the top right, it will move to live mode, and then everything is activated. And now at this moment you have a working event stream pipeline that is actively listening to listening to your API data. So you have configured, you have active Kafka configuration, and the topic is already listening. Okay, so the endpoint is already listening in that particular Kafka endpoint. Okay, so I think at this point we are done with event stream configuration. The next step is to build your notebook to ingest the data into this event house. So how do we do that? Because as I said just before, you have to copy the required Kafka configuration information, and then in the notebook we are going to configure the Kafka information, and then we are going to flush or push the data into event stream Kafka topic. So when you execute that notebook, since this is actively listening in that particular endpoint, the topic is already ready to listen, right? So you can just flush or push the data into Kafka topic, and then it will pull the data from the Kafka topic, and then it will land the data for you into Eventhouse. So that's the idea. So when you click on Eventstream, hit on create Eventstream, and then move to the live mode, you can always see the 3 different protocols that are there. And we are interested in Kafka protocol, and then the SaaS key authentication. We have already copied the required information, the bootstrap server and other information, topic information, and it is actively listening, in this endpoint. So when you're pushing the data to this topic, it will then stream the data in real time into your Eventhouse table that you have already configured. So that's the idea. Okay. So if you have any questions at this moment, feel free to post your questions in the comments below, or in the lesson below, and I'll be glad to answer those questions going forward. Okay, so with that, let us quickly move on to the notebook itself. Okay, so we will come back to the other 2 event streams where we are bringing the metadata, right? So the location sensor metadata as well, but we will go through that event stream after looking into the notebook. Okay, so there are 2 more event streams that I have, but I think location data event stream is sufficient. So I'll quickly go through that to see how you can load your dimension table or metadata table from different API resources from OpenAQ. Okay, so before that, let me open this notebook, ingest OpenAQ API sensor data. Okay, that's the notebook we are interested in. All right, so here so we are not tagging any data items as such. If you can see on the left side, no data sources added, because if you need to ingest, if you need to process data and ingest into, let's say, data warehouse or lakehouse, then you can tag your lakehouse or warehouse here. But in this case, we are just going to flush the data into my Kafka topic, which we've already configured as in our event stream gateway, right? So you can minimize this, and then all we are going to do is we'll quickly run through this code to understand what we are trying to do in this notebook. Okay, and then how are we going to ingest the real-time data from OpenAQ APIs. So I think first and foremost, you need to install the Confluent Kafka library. Okay, so because for every session you need to make sure you are installing this Python library, Kafka library. So go ahead and just install this in the first place, and then in this code we are importing requests JSON, and then from Confluent Kafka, which we have just installed, we are going to call the producer function, from Kafka, and then we are importing time. So these are the libraries I'm making sure to import, and then I'm configuring my API key. So if you remember, we have I told you about the Explore OpenAQ API portal. So you have to make sure you're generating that account details, and then fetch the API key from your account. Okay, so if you want, let me quickly show you how you can fetch your API key. Maybe I've already logged on to my account. So you can see here, I've already logged on to my account. So once you logged on, go to settings in your OpenAQ account, and then if you scroll down, you should see the API key. You can just copy, or you can regenerate the API key and then keep it somewhere. Okay, safe. Okay, so that's easy it is, and then bring that API key here, so because that's crucial, and then you're passing the URL. The actual API URL to bring the sensor data is this, so api.openaq.org version 3 API, and then location under locations resource, we are passing the location ID 2178, which is as I mentioned, the location Del Norte in New Mexico in US. Okay, so that's for the demonstration purposes, to keep things simple. For the entire course, I'm just going to stick to one particular location to bring the sensor readings and then show you in reports and dashboards. But feel free to explore different locations, and then, or you can bring in multiple locations and then look at the AQA indexes or your reports and dashboards you can build for multiple locations as well. Okay, so there are no restrictions as such. So it is not necessarily you need to follow through by looking at only one location. And I think /latest will bring the latest sensor data for that particular location, as I commented here. And then in the header section, we're going to pass that API key in the X API key parameter. You need to make sure you're passing the API key. Okay, so then it will be a personalized response that will be generated for your account. Okay, so the calls will be registered under your account. Okay, so and under the Kafka configuration, that's where you need to bring in the required information that you have copied from your Eventstream pipeline. As I mentioned, make sure you copy the bootstrap server information, protocol is there, mechanism will be same, and the username will be $connection string always, and then the password, you need to copy that. You have copied that JSS configuration, right? So there you can see the endpoint information. So completely copy the endpoint complete information from there. Okay, so it will have the shared key information, shared access key, and shared access key name and other information. So whatever you're copying from the JSS config, just copy the entire endpoint into the password. Okay, so this is how we should configure the Kafka right within the notebook. So then it is ready for us to flush our data from API into the Eventstream gateway, you can say. Okay, and all we are doing is we have already instantiated the producer from Kafka Confluent library, and then we are going to call that producer function and then pass the Kafka configuration that you have just configured, right? And also make sure you have copied the topic information, that you need to also copy the topic here. So these are the required configuration you need to make sure you copy. So don't just simply import the notebook that I'm going to attach in this lesson. So you can take the code, import the notebook, but do the required changes as per your Eventstream pipeline, and then you're ready to execute the notebook. Okay, and I think these code, you don't need to touch this code, I would say, if you're importing the same notebook what I'm sharing. But let's try and understand what we're trying to do in this definition, right? Fetch and send. That's going to ingest the latest sensor readings for that particular location. How are we going to ingest the data? So, and then we are going to call the API now in this particular line using the request library .get URL, and then we are passing the header also, and then storing the response here. So at this moment it will be a HTTP call that will be made. As you can see here, we have already configured the URL and other information, and the response status code we are checking. If it is not equal to 200, then it is a failure. Otherwise, we are going to store the JSON response. The results we are going to get in an array and then store it in results, and then we will iterate through that and then build the payload. So that's the idea. Okay, so from the JSON response from results section, we are going to iterate through that, and then we are building our payload, which contains sensor ID, and then the location ID, timestamp, value, actual value, sensor value, and then the latitude and longitude information. The coordinates also something we need to get, because when we are building our visuals, we can build some map visuals also. We have already built some map visuals, and then with the latitude and longitude information, you can clearly plot in the map, right? So with the latitude and longitude information. So that's the idea. We are going to also bring in latitude and longitude for that particular location, right? So we'll build our payload, we'll iterate and then build the payload. Okay, and then what we are going to do is we are going to use this function JSON dumps to convert, okay, so that payload string into JSON. Okay, so we are converting it into JSON string using this function once the payload is built, and then we can print the payload string to see how that looks like. As you can see, I'm printing here. This is already executed, so for you can run, and if you're facing any issues, feel free to get back to me. So you can see for every sensor ID, and then for the same location, different sensors, you can see the timestamp and the value, and the latitude longitude information will remain same. But for different sensors, for that location, you can see we are able to look at the response. Okay, we are trying to print it here, the payload string. Okay, so with the JSON dumps on the payload that we built, you can see the responses are coming in. And then finally, we are calling flush function, which will flush the data that we are getting from the API into the Kafka topic. So that's the idea. Okay, and this is actually wrapped in a function fetch and send. So once you are done with the definition, you need to make sure you call the function Okay, so to simulate the single ingestion run, right? And I think we are going to automate this as well on daily basis. We'll come to the automation part later, but once you're done with the notebook, execute it and see if you are able to ingest the real-time API data into your Eventhouse KQL table. So that's the idea. Okay, just look at the sample and then sample response, and then when you call the function, you should see all the sensor data flushed to the Kafka topic. Okay, so once you flush it, so that's a simple notebook, I would say, but you need to understand what we're trying to do inside with the required configuration. So when you execute this notebook, let's say, so what happens is for that particular location, so as you know, the event stream is actively listening with the Kafka topic that we have configured. So once you execute the notebook, you should see the data coming through. Okay, so in near real time, and then landing it in your Eventhouse KQL table. Okay, so you can see in the data preview the last execution done on today, right? So it is 21st of August that you can see. So since I've already automated this notebook, it brings me the data on daily basis. Okay, I've scheduled it already, so you can always see that. I'll go to the automation later. We'll talk about automation later, but since it's scheduled, you can see for different sensors for that location, I can see the sensor readings coming in and the latitude and longitude information also coming in, and you can see the event process time, the partition information, and then the event incurred UTC time as well. Okay, and I think you can cross check once you execute the notebook. You can come to the event stream and look at the data preview whether the Kafka topic correctly captured the data or if there is any issue. So you should see the data preview once you execute the data. If you are executing it today, you should see the data coming through for different sensors here in the data preview, and then you can go back to your Eventhouse. Let me go back to my Eventhouse, OpenAQ Quality Eventhouse. And I think you can see the system overview here. Okay, so what's the original size and compressed size and stuff like that. On the left side, you can click on database and you can see the KQL database is available for me to look at. And if you click on the database within Eventhouse, you can see the data ingestion happened. You can see the data activity tracker over time. And today you can see the data that got ingested today on daily basis. And you can always have a look at the data preview as well. Okay, so but let us look at some of the tables. I think this is the table that you have at this point you have configured, right? So for a particular location, you're going to ingest the sensor data, and let me expand this table for you. So at this point, once you are done with the ingestion through the notebook, you should look at your data preview in Eventstream and then come back to Eventhouse and make sure the table is created successfully inside your KQL database. With that location name itself, however you're configured, you have your destination, and then look at the data, right? So whether it is successfully ingested into a bronze layer. So a bronze layer is the actual table location name itself, that you can see the sensor ID, location name, then the timestamp information, and value, latitude, longitude information. All the information what you have gone through in the preview should be loaded in the table. Okay, so that's the idea. So with this, we can wrap up this video where we looked at the data ingestion into our bronze layer table. So we are going to look at this one single location in New Mexico, and we are bringing this different sensor readings for the same location and the value for the sensor real-time value for those. You can see it's coming on daily basis. So you can see for the last few days I've ingested the data, and you can see the data is successfully getting loaded on real-time basis every day. Okay, so with that we will wrap up this video, and in the next video we will look at the silver layer and talk more about how you can transform your data and stuff like that. So I'll see you in the next one. Thank you and welcome back. So before we jump on to the silver transformation, since we have ingested our data into a bronze table, so let us quickly look at two other event streams, for the metadata ingestion. So let us quickly look at that as well. So I'm in my workspace, and let me open this OpenAQ ES location data. So however you built your sensor to bring in your sensor data, you have already built at this point separate event stream. So you need to create another event stream. So to keep things clean, I would say create one more event stream to bring in the location metadata. Okay, location and sensor metadata. So same configuration. So copy the same steps what you have already followed. Copy the SAS key authentication details for Kafka somewhere. Because the details are going to be different. It is not going to be the same, right? So if you're creating a separate event stream or a new event stream, you need to again do the same steps to copy the details somewhere, and then when you're building the notebook, you need to retrieve those details. Okay, that's the idea, right? And again, when you're configuring the destination, if I can switch to edit mode, click on edit, you should see a different table is tagged now. Okay, so I'm going to call the location API from OpenAQ. We'll look at what that API URL is, and it will be shared in the notebook, so you can go through that. So we're going to run through that notebook also, again the same process. We are having an event stream, and we are going to ingest the data through our PySpark notebook. So that's the idea. Okay, and this time it is going to be landed in my dimension table, which is dim location, but in the same event house. Okay, so earlier we looked at how we can ingest the sensor data into the bronze bronze table, which is the actual location name itself. Now we are looking at the metadata ingestion. Okay, so but the idea is same. You need to copy the information and then configure the destination, but to a different table, to a dimension table in the same event house. Okay, so if I come back to the notebook that we have created for metadata ingestion, so here I have this ingest OpenAQ API location data. Okay, so click on that notebook, and the notebook will be shared in the lesson below. Okay, so you can download the resource, and then you can import and then do the required configuration and execute it. Okay, so you no need to write this PySpark code from the scratch. You can import the notebook always in your workspace. If you go to workspace, there is an option to import your notebook, okay, from your computer. You can download the resource that I shared and then import, and then start making the changes and then execute. Okay, so don't simply run the notebook after importing. So you need to, as I mentioned clearly, you need to do a lot of configuration inside the notebook based on the event stream that you created and your API key and a lot of information. So the code is going to be same what we just looked at for sensor data ingestion. This time it's going to be the metadata ingestion. The only thing that is different is the API URL that you can see here for the same location, which is 2178 for the location Del Norte in New Mexico in US. The API is something different. This time we are not calling the /latest. If you look at the sensor reading API, it is location/location ID/latest. That will bring the latest measurements for that particular location. But this API URL is something we are going to look at the metadata for that location. So location/ you can directly pass in 2178 also, or from the parameter. Okay, in a version 3 API. And then the Kafka configuration, you need to make sure it comes in from the new event stream that you created for metadata ingestion. Okay, and then the producer configuration, everything else remains same. Now the definition is going to be something different. Now we are saying it's we're going to fetch and send the location metadata, not the sensor data for that location. So you're going to call the URL using the request library, and then you will iterate, you will build the payload now, right? So it is going to be the location information. So from the response, you're going to get the location ID, location name, country information, latitude, longitude, and the type information, right? So the time zone as well. Okay, so all these will be captured. Okay, and also this is the top level metadata that you're going to get from that response for the location. And then you're also going to get the sensor information from the same API. Okay, so we are not looking at a different API to get the sensor metadata because if you look at the response from the previous API to get the actual latest measurements, we have only the sensor ID, but you don't know what those sensor IDs are, right? So for that, you need to get the metadata separately, and then you need to perform the required joins to try and understand what those sensor IDs are, right? So it could be PM₂.₅, PM₁, different pollutants we are talking about. So you need to make sure you need to bring in the metadata and then perform the join to understand what those sensor readings are from the latest measurements, I would say, right? Well, so here from result set, you can see we have sensors section separately. So we are going to iterate through that and then build the payload. Okay, so how are we building the payload? So here you're building this location information, and then you're also kind of constructing the location information inside the payload. And apart from the location information, we're also going to bring in the sensor ID, parameter information, okay, and the actual parameter what we are trying to look at, and then the units information, and then the display name. So that will help me to understand what is the actual pollutant type that we are looking at, right, for the measurements that we are reading for that particular location. Okay, and then you're going to build that, okay, payload, and then you're going to flush it. Okay, so you're going to in the produce function, you need to make sure you pass the topic and then the payload once you call the JSON dumps to make sure you're converting it into a JSON string, and then flush it into the Kafka topic. So that will flush all of your location metadata into the Kafka topic. So when you call this function, this is a different function we are looking at, right? So fetch and send location metadata. Then you make sure you call the function, and that will kind of output this print statements for you, like sending metadata. You can see the location ID, location name, countries, United States, latitude, longitude information, time zone. In America, Denver, type its metadata, then the sensor ID, and what that sensor ID means. It is CO, and the units, parts per million, and then the display name. For example, let us look at something like PM₂.₅, which you might be probably already aware. So it is something we are measuring in this, and then the sensor ID is this, and then the value. I cannot see value here, right? The sensor value is something the latest measurements API brought in, and then we have already loaded into our bronze layer, and this API will call the locations API, and then all we are going to do is we are going to bring in those metadata information for me to store in my dimension table, so that I can perform the required joins and then identify, okay, what is the actual value that we brought in for PM₂.₅ and PM₁ and stuff like that. Okay, so I hope it's clear. So this API we are calling from notebook, and we built a separate event stream to ingest the metadata into my dim location table. So once you execute this notebook, come back to the KQL database that you have built, and then open the KQL database. And now I think once you execute the second notebook, okay, you should see the dim location is loaded. Okay, so if I can expand this table quickly, so you should see the location ID, location name, country, latitude, longitude information, type. So whatever information that you captured from the locations API, that metadata we have loaded into the dim location table. And this is something you need not automate, right? So this is a metadata table. It's a one-off load, I would say. So once you have loaded this metadata and the dimension is loaded, then you're good. So it is going to be a one-time load to bring in the metadata for that particular location. Then you're good to go. Okay, so it's a one-time load, you can say, right? So, and you can see all the display, the pollutant names are there, and the sensor ID is captured. Because if you look at the other table quickly, the bronze table with the location name, all you can see is the sensor ID and location ID and stuff like that, right? So you don't know what the sensor ID means, right? So that's the reason we brought in the metadata in dim location, and that will tell you what those sensor IDs are. So for example, 3920 is PM₂.₅, 3919 is PM₁. So basically we brought in the metadata and loaded into the dim location table. Okay, with that we end this video, and I will see you in the next one. Thank you. And welcome back. So now that we have ingested our raw data into the bronze layer in KQL database inside Eventhouse, so it is time for us to look at how you can enrich the data. So we have also seen how you can bring in the location and sensor metadata using different API resources into the DIM location table. So that has both the location information as well as the sensor IDs and the respective pollutant information as well, right? So we had a quick look at that. So I think so do not restrict yourself to only these two API resources. So as I've already mentioned, so if I can quickly navigate to OpenAQ.org. So we have already looked at quite a lot of resources, API resources, right? So if you just navigate to explore your data, explore the data, and then quickly look at the documentation real quickly. So give me a moment. So you can go to developer documentation and get started. So on the left hand side, you can clearly see there are quite a lot of resources. We already talked about it during the start of the course. So we have already leveraged the latest to bring in the sensor measurements, the latest readings on day-by-day basis for one particular location. So as I mentioned, you can explore different locations and then bring in sensor readings on daily basis from different locations. So that's one assignment. Probably when you follow through this course, you can try and challenge yourself to bring in data from different locations. So it is not necessarily, again, you need to just follow what I'm demonstrating here. So just for the sake of simplicity, I'm just demonstrating with one particular location and couple of APIs, but feel free to explore all the other APIs like countries, instruments, and then see how we can bring those metadata and perform the joins and enrich your bronze table further, right? Enrich your bronze table further and then load it into your silver layer in your medallion architectural pattern, right? So, but as of now, we have loaded the latest measurements for one particular location in New Mexico and then loaded into the bronze table using this latest API resource. And then we also leveraged this locations API resource, and then we passed the location information. We took the same sample and then we called the API and then loaded the, if you have seen, we have brought in the location information, and then in the sensors data set, you have all the required information related to every sensor and the metadata related to those. But you can explore other APIs if you want, and then try and see if you can build event streams for those metadata APIs as well to bring in and then enrich your data set further. So that's probably an assignment for you. You can explore further. I'll share the link in the description again. You can go through it. Okay, coming back to Fabric portal. So here we are in our workspace, air quality real-time analytics. So now what we will do is we will move on to our Eventhouse and then our KQL database inside. So when you create your Eventhouse, by default a KQL database will be created, and then the query set will also be created. A KQL query set will also be created for you to kind of explore your data, do some analysis, transform your data, and then also you can do the end-to-end kind of, the transformation to load your fact table also. So as a part of this course, so apart from PySpark notebooks that we have leveraged to load the data from APIs into our raw tables, further transformations from raw to silver and then to the gold fact curated data, we are going to leverage the KQL queries to see how we can enrich our data, how we can transform the data and load it into silver layer, and then how we can load our fact table as well, okay, by joining with different dimensions. So we'll also look at different dimensions. So we have already loaded our location dimension, we will also bring in some shortcuts from other workspace to like dim date and all. You don't need to create from scratch. If you have already created such dimensions, reusable dimensions, I would say, in other workspaces, you can definitely bring those using shortcut feature and leverage for this solution as well. Okay, so let me open the OpenAQ Eventhouse. Let's get into the Eventhouse, and then it will load the system overview for you, and then just get into the KQL database. Then you will have the list of tables loaded, right? So you should have this location table. If you're loading multiple locations, you might have more than one table in your solution. one table per location that you have loaded the raw sensor data from the latest API resource from OpenAQ. Okay, got it. So now I think what we will do is, at this point in time, you should have the raw table and then the dim location, right? So don't worry about other tables, we are going to look at it. So make sure you have loaded the raw tables and then the dimension location table. Now what we will do is, inside the KQL database, you can also navigate to the query set, which will be created automatically at the time of creating the event house. Okay, let me open the query set real quickly. So I think you can write n number of queries like SQL queries scripts. You can write KQL query scripts inside your event house query set. You can open multiple windows and then start writing KQL queries. And I think if you're completely new to technology, KQL technology, it's custom query language. Maybe I will provide the link to my to one of my course where I talked about the KQL basics. You can go through the basics and then read more about it in Microsoft documentation to know more about the operators, how you can write the syntaxes, and it's pretty much similar to SQL. You know, if you're already familiar with SQL, I would say it is easy for you to learn KQL. Okay, only it's like sequencing. You know, you need to have this kind of pipe operator, and then the join syntax going to be same, and then we are going to use kind left outer, and then we join with other table on which column, and then instead of select you will have something called project to bring the data out. And then I think mostly the syntax, like the operators that use join, order by, everything remains same. You know, it aligns well with SQL, but some changes, like instead of select you will have project. So I would encourage you to go through that video and the Microsoft documentation to learn more about different operators that you have in KQL. So you'll get some idea before you start writing some queries inside the query set here. Okay, so let us quickly look at how we can enrich the data, or how we can perform different joins using KQL queries. One sample here that I have here. So as I mentioned here, I think the structure is something like, it will be kind of sequential, right? So you will have the table name, instead of like in SQL you will say select star from table. So here the table names comes first, and then the operators separated by pipe, and then again the actions, like, you know, if you want to select some specific columns, so everything will be separated by pipe in KQL kind of a world, you can say. So for this example, you have this del note albeq, which is our raw table that we have loaded our sensor data into this particular table, and I'm going to join it with, I'm doing left outer join with my dim location table. So at this point you should have these two tables loaded from your OpenAQ APIs, right? So we are basically going to see if I can enrich this data with this location information on the basis of sensor ID, because the common column that joins these two tables is sensor ID. So I told you, right? So the latest measurements comes with only sensor ID, and you will have sensor ID information and the related pollutant type and the other metadata that we have loaded in the dimension table. So we are basically doing the left outer, and then we are projecting the sensor ID, location name, and then the pollutant parameter, we can call it as pollutant, and then the units, and we are joining on the basis of sensor ID. Okay, and then once you perform the join, you're going to bring out some columns that you need to display. So that's why we are saying project these columns and then order it by the timestamp UTC in descending order. So let me run this and show you what we get. So there you go, we got the result. Let me hide this so it will be easy to view. So here you can see we brought in, so whatever you're projecting here, you will be able to see those columns, you know, kind of select in SQL, you can say that. So now you have the sensor ID coming in, location ID, location name, pollutant. So we name the parameter as pollutant. So now you can clearly see the respective sensor ID and the pollutant information. And then the location is going to be a single location, but in case if you brought in multiple locations, right? So anyway, I think we are going to load this raw table for one particular location. If you have multiple locations, you will have different tables, right? But if you're performing join on any specific table, the location ID is going to be same and location name is same, right? Which is del note in my case. okay, and the pollutant unit information, and then the value itself. So now you can clearly look at the information, right? So with only this raw table, you cannot derive as such what that pollutant is, but once you perform the required joins to the location dimension that we brought in the metadata from another API, location API from OpenAQ. So I can clearly see the values like PM₂ is 7.1 and PM₁ is 20, something like that. So okay, so now I think at the time of reporting, you can derive some meaningful insights about these metrics. Okay, so you may be probably already aware. You can just Google out what is the ideal or the good target. If you breach that target, the air quality may be poor to breathe, right? So which will harm our health as well. So I think we can get into the specifics of it, but at least we know what that pollutant type in these locations. We have multiple pollutant types, okay, for different days that you can see 21, and then yeah, so I'm bringing this data on daily basis. So you are looking at different pollutants and then the value, and then the latitude and longitude information is going to be same. So if you can use this to plot it in your map visual in dashboard for nice visuals, you can say, right? So with that, we wrap up this video. So you can write or you can practice, I would say, a lot of KQL syntaxes, operators, and then try and write as much as queries as possible at this moment to practice yourselves and then be familiar with the KQL syntaxes. And then you can run some queries, by performing joins like this, and then do some analysis on your data. Okay. So in the next video, we will look at the silver transformation, wherein how we can kind of enrich, once we enrich the data, how we can load our silver layer to take our data further from raw layer. Okay, so I'll see you in the next one. Thank you and welcome back. So in this video, we will look at the silver transformation script. So basically, as I already mentioned, so we are going to have this KQL script for our transformation. So to see how we can do the feature engineering if you want to extend some columns in your existing data set, and if you want to kind of clean your data set and then transform the data. So all those operations you can do within the KQL script experience itself, within the KQL query set, as you can see here. So we will quickly run through the script that you are seeing here for silver transformation, and then we're going to load this silver table from our raw table for that particular location. So if you're looking at multiple locations, as I mentioned already, you can probably looking at multiple silver tables for you to load for every single location, right? So we will quickly run through the script. So and I hope it's easy to follow since the syntax is not very complex. So if you're already familiar with some SQL knowledge, this is easy to follow, I would say. So but I will attach the YouTube video link for KQL basics. So you can go through the intro to KQL, and then you can read more about different operators that you can use and different functions that you can use with the help of Microsoft documentation, and that will help you to clear all your doubts and then be ready. So do a bit of practice, take that as an assignment, do a bit of practice on KQL so that you'll be familiar with the KQL scripts and syntaxes, and then you can start writing scripts like this to transform your data, I would say, right? So okay, let us quickly go through the script, and the same script will also be shared in the lesson. And also if you're watching this in YouTube, you need to enroll in the course in the Teachable platform so that you can gain access to all of these scripts basically, right? So if you're watching in YouTube, you cannot gain access to all of the downloadable resources. Okay, so if you need all these resources to be downloadable, then you need to enroll in the course in the platform, and it is a paid enrollment. So you can feel free to enroll in the course, and the link to the Teachable course enrollment will be provided in the description so that you can go through it if you're watching this in YouTube, so that you can gain access to all of the materials related to this course in the LMS platform. Okay, and you will get lifetime access as well. Okay, so having said that, let's quickly run through the KQL script. So it is not quite complex, but we will quickly run through the script and see what we are trying to do. So basically, dot set or append, what it will do is it will try to kind of append your data. Okay, so if it is if it's a new table, okay, so it will try to create that table for you. Okay, and then going forward, anything that you're running on incremental basis will be appended. So we are not replacing or overwriting. I'll show you how we can make the script as incremental script, so that every day you can schedule the script in a pipeline. So we'll also be looking at that once you run this for one time. If you are building this today, so from tomorrow you can schedule this KQL script so that every day it will run, okay, based on the timestamp that we're going to look at, and then it will start appending the data into the silver table. Okay, so that's our silver table, and this is our bronze table, as you know. So this is how the syntax goes, and then as I mentioned, every operator will be preceded by the pipe operator. Okay, so we are doing a couple of joins here, left outer joins to dim location, and then we are projecting some columns as we have seen on sensor ID column, the common column, and then we are doing one more join on dim pollutant. But I think, as I mentioned, I think no, you probably not require this dim pollutant, because we have already looked at the sensor metadata as well as location metadata as a part of dim location. So maybe you can, if you need more information like description or more details related to every pollutant, you can bring in this dimension. Okay, but I'm basically doing one more join to dim pollutant on pollutant code. Okay, but I haven't shown the respective API, but I think you feel free to kind of explore different resource API, as I mentioned. So it is like you have parameters API that will help you to gain access to detailed information about the pollutant itself. Okay, so I'll leave it up to you, so you explore all of the available APIs so that you can build your own solution. Okay, so but I'm providing the head start here, or jump start, for you to get started. Okay, so that's how we are performing the joins to two different dimensions. And then in stage one, we are trying to extend the timestamp. Okay, so basically we have this timestamp UTC column, and then we are trying to, when you use extend, basically you're creating a new column on the fly and then applying some transformation. So in case of this timestamp UTC, as you can see, it is in string. So basically I need to do the required conversion to date time, and then I can store it in a different column, okay, by using extend operator. Okay, and in stage two, we are trying to derive the metrics like hour, day, and month from the timestamp itself. How are we doing that? So using the datetime part function, we are trying to derive the hour from timestamp that we extended, and day of the month we are using format datetime, and then we are passing, I need the day of the month in DD format, then I need the month in format out of the timestamp that we extended. So as simple as that. Okay, and in stage three, you can also do some feature engineering, right? As I mentioned, you can derive some columns based on the existing columns. So KQL script will come in handy to do the feature engineering as well. So here I'm trying to extend, kind of adding a new column called pollution category, and then you can use the case statement as you usually use in SQL, and then you can based on the pollutant name, okay, and then the value, when it is lesser than or equal to 12, that's a good target. If it's lesser than or equal to 35.4 moderate, or something that is unhealthy, or above 50 unhealthy, right? Unhealthy for sensitive. And if it's beyond this level, then we tag it as very unhealthy, okay, or unknown. So that's how you can do some bit of feature engineering as well to prepare your data for further downstream process, I would say. Okay, and then we are finally projecting the required columns. Once you perform the required joins, we are projecting, once we perform the join, and then we extended some columns, and then you can see finally I'm projecting the required columns, that brings in the pollutant name, and you can see the pollution gate category that we extended, and latitude, longitude. So whatever columns that you require, once you perform the required transformations, you can try to do a project which is nothing but a select in SQL to bring in all of the columns that you require. Okay, and then finally we are ordering it by timestamp in descending order. So I hope it's easy to follow, because KQL is not that complex, but it's critical skill set if you're working on a real-time use case, right? So because you prepare your data in Eventhouse, and then you need to know the KQL technology for your real-time data analysis. Okay, and even you can do the transformations as well, and then even you can schedule the KQL scripts like you usually schedule your pipelines, that contains PySpark scripts. So similarly, you can schedule your KQL scripts as well to run every day and do the required transformations for you. So once I run the script, so I'm not running this at the moment since I already executed this and loaded the table. If we come back to the tables, so let us have a look at the Del Norte Silver. So we can give a try and run this script to see if the silver table is getting loaded. If you're facing any issues, please feel free to reach out to me, okay, in the comment section below in the lesson. Okay, so here you can have a look at the data preview. So you remember we have this timestamp where we converted it into date time, then we derived some metrics out of the timestamp that you can see month and all the information, and you can see the pollutant name, value, and preferred unit, and the pollution category. So you can see we derived this column, we engineered this column, right, based on the kind of the values. So I think this pollution category we did derive based on PM₂.₅, but you can use the same concept or same technique to derive or categorize the pollution category based on different levels that okay, but I'm just giving you an example based on PM₂.₅. So since it's 7.5, it is in good category, but if it breaches a certain level, then we will tag the category accordingly. So that will be helpful for analysis as well. Okay, so yeah, so that's how we did some basic transformations, but you need not follow the same script. Maybe you can explore further and do a lot of transformations out of this data, and feel free to reach out to me. You can tell me you came up with a script that performed a lot of transformations, and you did something interesting, and if you want to share, you can definitely share with everyone, right, in our community. Okay, so that's a quick transformation that we had a look, and maybe let me quickly also let you know how you can. So let me come back to the query set and minimize this. So now let me tell you how you can schedule this KQL script, right? So I think we will look at the automation towards the end of the course, end to end, so that you can automate the entire pipeline. But if you're trying to automate this and bring in the data on incremental basis, so all you need to do is, you can see there is a commented line here. So I think during the first load also you can enable this, but I just commented this part of code. So you can see I'm using var clause on the bronze table and using the toDateTime function on the timestamp UTC column, which is greater than or equal to start of day now. What happens is, so it will try to pull the records only that got loaded today. Okay, so when you schedule the script, it is fine enough to fetch only the records that got incrementally loaded today, and then it will try to append it into the silver table. So as simple as that. Okay, so I hope it's easy and clear to you, right? So we are just using that var clause to filter out the records and then try to append it to the silver table. So you can clearly see here in my silver table. So far I think quite a few days the data has been loaded, so we can have a quick look at the data. So you can see here 21st data got loaded, 20th. I think you can have a look at it in the activity tracker itself, so that you can see here 21 rows got loaded on 19th, 20th, and 21. So you no need to drill through the data. They're providing this nice data activity tracker with the ingestion and the last runtime and stuff like that. Okay, so that will be easy to track your table ingestion performance. Okay, so that's about it, with respect to silver transformation. If you have any queries, feel free to comment. And that's it for this video, and I think probably in the next video we will talk about the dimensional modeling and start building our fact table from our silver table, and then we will try and look at the semantic modeling and build the star schema to build that relationships between fact and dimensions, and then we prepare for the reporting. Okay, so I'll see you in the next one. Thank you. Hi and welcome back. So I think in this video we are going to talk about dimensional modeling, and we are going to build a fact table from our silver table that we built just before. Okay, and then we will also look at a few dimensions. So we already brought in dim location dimension, and I think we can also probably create a shortcut if you already have date dimension. And I think feel free to add more dimensions, as I mentioned, by exploring different API resources available in OpenAQ, and that will help you to kind of extend your data model as such with a lot of dimensions that you can bring in. But for the simplicity, I'm just bringing in a couple of dimensions, and then I'm going to build my dimensional model with fact and dimensions right within the Eventhouse KQL database, and then we'll be preparing for reporting. Okay, so we are going to have a fact table. So we are going to talk about the grain of the fact table, because when you start building your semantic model, it is crucial for you to understand the kind of grain that you are looking at in fact table, right? So whether you're looking at day grain or monthly grain or whatever it is. So, but you need to know what every single record that you're going to load in fact table represents, right? So that's the grain that we're talking about here. And I think in our case here, our fact table is going to be sensor readings. So which means, like, let's say we are now looking at a single location, Del Norte in New Mexico in US, and we have different pollutants, right? So we have close to 10 or 12 pollutants, n number of pollutants, and then the sensor readings are coming in, let's say for PM₂.₅, PM₁₀, for different pollutants, right? It might be 10 or 20, doesn't matter. It differs from location to location, but for one location, for the demo purposes, we are bringing in multiple pollutants for the same location and the values for those. So the idea here is the grain of fact table is going to have the pollutant and location wise sensor readings. Okay, so that's the grain that we are looking at, which means, like, if you're having 10 pollutants for a single location, so we are going to see 10 records in my fact table for that particular location. You will have 10 different records. We'll have 10 different records. Each record will hold the sensor reading for that particular pollutant. So I hope that makes sense, right? So that's the level of grain that we are looking at. So in my fact table, so it is quite crucial, as I said. You know, if for any semantic model that you're building, you need to decide on the grain. In finance, it could be different, right? So you have to make that decision. You know how customers wanted to have a look at the data. So if you need to do that required aggregation before you load fact table, so you might be having day by day data, financial transactions coming in. So for example, I'm just giving in fact table, if you're looking at a weekly grain or monthly grain, then you need to kind of do the required aggregation and then load the data into the fact table. So because since you are looking at a weekly kind of a grain, you need to aggregate your data. But in our case, in our silver table, we are already having the grain that we are looking at in the fact table. So which means, like, I may not need to do the aggregations as such in my data set that I hold in the silver table to load the fact table. So probably all I need to do is, since the grain that I have in my silver table is already aligning with my fact table grain, which is location wise pollutant sensor readings, then all I can do is I can just perform the required connections to dimensions and then load my fact table. So then I can prepare for my reporting. I hope that makes sense. And if you have more questions on deciding the fact grain, you can ask me in comment section and I'm happy to answer those. But keep in mind, when you're looking at a dimensional model, you have to be very clear on what the grain is in your fact table and whether you need the required aggregation when you're loading the fact table, or if your data is already in that grain, there is no need to do the aggregation at all. You can simply load the fact table. Okay, and I think the dimensions, as I spoke about, we are going to look at few dimensions, but feel free to bring in more dimensions from the OpenAQ API resources and challenge the solution, I would say. Okay, so let us move on. So I think let us go back to, let me go back to I think in this presentation, I think, yeah, so in the slide, we are talking about querying the sensor data with KQL. So we are just going to join the fact and dimension tables and then load our fact table. And I think in this case, we are not going to do any aggregation, but in case if required, with the KQL script, you can do the real-time aggregation within the KQL experience, and then you can start loading your fact table for dimensional modeling. Okay, so that's the idea. If I come back to my Fabric portal, so we are inside the Eventhouse already, right? And we had a look at the silver table. So let me take you through the fact loading script real quickly. So let me navigate to the query set and minimize this. So before you start loading your fact table, so you can just decide on the schema for the fact table. Okay, so you can see here. So I've already decided, so I'm just going to have this kind of a schema and enforce the schema for my fact, and I named the fact table as fact sensor daily. Okay, so we are going to get daily data for every pollutant for that particular location. So as I mentioned, if you're looking at 10 pollutants for a particular location, you should receive 10 records, one for each pollutant on a daily basis. So it is meaningful to name fact sensor daily. Okay, and we are creating this table within the Eventhouse with event date, location ID, location name, sensor ID, pollutant name, the value, the actual sensor reading, preferred unit, latitude and longitude. So these are more than enough or sufficient for me to build my dimensional model. And I think I'm bringing in location name and all, but usually when you load the fact table, you will kind of perform the joins and then take only the required keys. But I think just for demonstration purposes, I'm bringing in the location ID as well as location name, but feel free to get rid of this location name and probably focus only on the keys like location ID and sensor ID without bringing location name and pollutant name. So okay, just for readability purposes, I'm bringing this. Otherwise, as a thumb rule, when you load fact table, you need to kind of load only the keys from your dimension table, and I think all the dimensional keys should be there, and then you should have your facts. That's how we need to ideally structure our fact table. But just for demonstration purposes, I'm bringing in the other columns, so don't worry too much about it. Okay, but I hope you got the idea, right? So yeah, so I think just create this table, and then we can quickly look at the script. So again, for the fact loading, I'm not relying on PySpark script or the PySpark notebook. Okay, I'm just going to do the required loading by joining with different dimensions within the KQL experience itself. Okay, like how we did the silver transformation, I'm just going to load the fact table with this KQL script. So we'll quickly run through. It's not a big script, it's very easy to just do it, but feel free to expand this. As I mentioned, just for demonstration purposes, we are sticking to one particular or couple of dimensions and then loading the fact table, but challenge this solution and then extend as much as possible as you can, and then build your solution, build your complex solution. Okay, so and I'm ready to help you guys as well if you have any doubts when you're trying to bring in other resource APIs from OpenAQ. Okay, and again, I think we are trying to set or append fact sensor daily, and from the silver table now we are going to extract the data. And you can use extend function event date, and I'm going to say start of the day because I need only the date. So I'm using the start of day function from timestamp and then extracting event date. And again, this code is actually commented. So what we're trying to do is I'm using a where clause. So if you're trying to automate this for incremental ingestion into fact table, we're going to filter the data based on this extended event date, and I'm saying start of the day now, which filters only the records that are coming in incrementally today. Okay, so as simple as that. Okay, and then you can start projecting the columns, right? Like event date, location ID, location name, sensor ID, pollutant name, value, preferred unit, latitude, longitude. See, I think you might be wondering, I'm not performing any joins here at the moment because all the required informations I have here already in the silver table, but ideally you should perform the required joins to the location dimension and then fetch only the location ID. Okay, and then take it to your fact table. But I think for demonstration purposes, I'm pulling all the information from the silver table, and I'm just loading it into the fact table, okay, just just to keep things simple, okay. So but I think as we have seen in silver transformation, we have performed the required joins, right, when we're loading the silver table. But I think all you need to do when you're creating the loading the fact table, make sure you perform the required joins to your dimension table and then load only the keys, you can say, okay. But here I think if you look at the location dimension here real quickly, let me open that location dimension. So if I expand this, you'll have your location ID, a location name, and other information, right? So I think you can have a probably ideally you should have a kind of a primary key, a kind of a stuff, and then you can take those keys into the fact table. That's how it should ideally work. But to keep things simple, I'm just demonstrating by pulling the required information directly into the fact table. And then we can see at the time of semantic modeling, I'm going to show you how you can establish the connection between the fact table to the dimensions based on the common columns, okay. But don't worry too much about it. So that's what I wanted to quickly show you. So I think, yeah, it's a simple script so that you can project all of the columns from silver table, and if you want to perform join and then extract the keys, do it. I think it's not complex, I would say. You can definitely do it and then bring the required keys into the fact table, then prepare it. But this is not the table. Just for information, we are going to build a semantic model. It is going to be another table, which is fact sensor. Let me show you that. That will have a lot of extension to it. So it is the fact sensor Calc, so which we are going to look at it in the next video, where we do a lot of extensions and then derive some columns, okay, based on the existing data, and then prepare for our semantic modeling, okay. But coming back to loading this fact sensor daily, so on top of this table we'll be building the final table, which is fact sensor Calc table, that will be used for semantic modeling, okay. And we are finally ordering it by event date when loading the fact table, okay. So, and as I mentioned, this script will also be scheduled for incremental ingestion. That will be easy to automate and then load the data on daily basis into fact sensor daily, okay. So let me quickly show you how that table looks once you execute that KQL script. We can have the data activity tracker here. We are loading 21 rows on daily basis for this particular location. If I expand this, you can see the event date is created, location ID, location name. So ideally in a fact table, you won't see the dimension details, right? So you'll have only the keys. So that's what I mentioned. So don't worry about it. You might have a question why you're seeing all the dimensional data in the fact table itself. So just for demonstration purposes, as I mentioned, just ignore it, I would say, and then you can, if you want, you can just perform the joins and then load the keys. But that's of no harm, so we're not breaking the rule as such. So just for demonstration, we are keeping things simple, okay. So, but feel free to extend the solution accordingly and then build your semantic model, okay. So so you can see the sensor ID, pollutant name, value information, and latitude, longitude, all the information you can see here, okay. So but there are opportunities to extend the solution to bring in a lot of dimensions, as I mentioned, from the different resource APIs that you can look at, and then build multiple dimensions and then perform the join and then load the fact table. So I'll leave it to you as an assignment. You can definitely explore such APIs and then extend the solution as much as you can, okay. So that's a homework for you, I would say, okay. And let us come back to, okay, so maybe with this we will end this video, and then in the next video probably we'll quickly look at how we can build the final fact table with calculations or measures that we are building with the KQL script itself. So I'll see you in the next one. Thank you. Hi and welcome back. So I think until this point we have loaded our fact table with the help of KQL script. So in this video we will quickly look at how we can build some measures right within the KQL experience, okay. So by extending a lot of columns and then calculate some of the measures right within the KQL experience, and then load your final table for semantic modeling, which is the fact sensor calc. Okay, so that is going to be based out of fact sensor daily table. So we'll quickly run through this KQL script, and I'll take you through this, and the script will also be shared. And if you're watching this on YouTube, you need to enroll in the course to gain access to all of the downloadable resources, these KQL scripts, so that you can practice along as and when you follow along the course. Okay, so let us quickly run through this script. So we are going to basically append to the fact sensor calc table. Okay, so, and I think you also need to create the schema for that as well, like how you did create the table for fact sensor daily. Make sure you define the schema for fact sensor calc as well, which will have event date, sensor ID, location ID, pollutant name, value, and then we are going to derive some metrics or measures in KQL. So we are going to get the previous value and the daily change, okay, and which is real type, and then the moving average 7-day. So these are some of the metrics I'm going to derive with the KQL experience, and you can also derive these measures with DAX as well when you're designing your data model there. That's something you can do as well, but I think these are pre-computed when you're loading the data set itself. Okay, so I've already talked in detail about what's the difference between, what are the advantages of pre-computing your data set or the computation at the time of DAX execution, in using DAX. So I think maybe that I will share the link as well. You can go through and try and understand what are the benefits of or what are the pros and cons of doing both of these options, right? So pre-computing in your data set or at the run, on the fly using DAX. Okay, so we're going to look at the daily change and moving average 7-day itself, but you tell me what are the other different measures that you can think of to extend the solution further. So that is again probably an assignment to you. You can probably do the required homework and then extend the solution and then let me know. Okay, and then we are bringing the latitude and longitude, and that's going to be my fact sensor calc schema. So coming back to the load script, so let's quickly run through that. So we're going to extract the data from fact sensor daily, and again for incremental ingestion we are going to use var class, where is not empty, trim the pollutant name, because I think we have to make sure the pollutant name is not empty, and we are also using trim function and then checking if it's empty or not. Okay, so that we can filter out some empty or null values in the pollutant name. Okay, and then what we are doing is we are trying to summarize based on, we are averaging out the value by these columns, based on event date, sensor ID, location ID, because I think in the data set you need to make sure there are no duplicate records in a particular location for pollutants, right? So you have to make sure there are no duplicates, otherwise you will run into issues. So we are basically trying to summarize because I have seen there are duplicates coming in, so you need to make sure you average out the value, sensor value, based on event date, sensor ID, location, pollutant name, and latitude and longitude. I think this should be the key to aggregate your data and then average out the value based on, for any particular location for that particular date, the data coming in for every sensor and pollutant name for that particular location. You're going to average out using the summarize operator. Okay, and then you're going to extend the event date and then converting it into to date time and then storing it in event date time, and then we are ordering it by sensor ID, pollutant name, and event date time in ascending order. Okay, so we have to do this. I'll tell you why we are doing this, and then we are kind of ordering it in ascending order, because we are going to look at the previous value for every pollutant for a particular day, and then we are going to calculate the daily change. And to achieve that, you have to make sure you have the data in correct order, in ascending order, right? And also it should be in a particular order. So that's why we are ordering it by sensor ID, pollutant name, and then the date also. That's why we are doing the conversion, and then the key should be this. to order your data. Then it'll have the data in correct order for me to look at the previous value and then calculate the daily change for every pollutant on day-by-day basis. Okay, that can be achieved, and that's the reason we are summarizing the data and then extending, and then we are ordering it in the first place based on the records or data that I have in fact sensor daily, and then it will be ready to perform some operations on top of it. And then I'm calling serialize operator for me to perform, because the previous function that you're going to use to calculate the previous value require you to do some serialization. That's a requirement. Okay, so you need to do the required serialization and then extend. So I'm going to calculate the previous value, and if the sensor ID is equal to previous sensor ID, so since we already ordered the data, we are also performing that check here. Okay, and then we are looking at the pollutant name also. If it's equal to the previous pollutant name, then we are using this previous function and then extracting the value. Otherwise, we are keeping it as null. Okay, if it's not matching these conditions, and we are storing that in previous value once we ordered the data. So that will store the previous value for any pollutant for a day for that particular record. Okay, so we'll look at examples to keep things simple. So maybe I'll quickly show you how that is getting stored, right? So the idea of calculating this previous value is to calculate the daily change. So in the next line, what I'm trying to do is I'm calculating the daily change. How? Using if is not null the previous value, then the value minus previous value will get me the daily change. Okay, that's as simple as that. Okay, let us quickly also look at, before we look at the data, how these metrics are derived in the table once we execute the script. So we will also try and look at the moving average 7-day. Okay, so the idea is to smoothen out the data. So that's the reason we are calculating the moving average for the last 7 days. That will try and eliminate the noise in the data, you can say, and try to smoothen out the data. So that will help you to derive some patterns out of your data. And how do we do that? We are basically using if function by extending a new column, and if the value, if any of the previous record if the value is null using pre-function, or we are using kind of based on sensor ID and pollutant name, we are checking if the sensor ID matches with the previous row, and then the second to the previous row, and the last 7 records we are checking if the sensor ID and pollutant name matches. If it's not matching, then we are kind of the moving average 7-day will be recorded as null, that you can see. Otherwise, we will go ahead and calculate our moving average 7-day if it satisfies these conditions, right? So in the second part, you can clearly see we are rounding the value from the current record to the previous record up to the last 7 records. Okay, so we are averaging it out and then rounding it to 2, and that will give us the moving average 7-day for the and this we are doing on the basis of every pollutant type, right? So that's the reason we earlier summarized the data, and then we are now keeping the records in order for us to be able to calculate the previous value, daily change, and then the moving average 7-day. And I hope that's clear to you. If you have any questions, please feel free to reach out to me. And all these kind of engineering or metrics measure derivation we are doing right within the KQL experience, as you can see, and it is quite faster and easy as well, okay, to derive your measures and then pre-compute the data values and then store it in your final fact table that you'll be using for your semantic modeling. And then we will also kind of the daily change, we are also rounding it to 2 to avoid any not having more than 2 decimal points, so we are rounding it to 2. And then moving average also we are rounding it to 2 again. I think we already did rounding here, so maybe this is not required. And then we are extending event date, and then we are converting the event date dt to date time, and then we are following this format in the year, month, and date format for consistency purposes. And then we are finally projecting or selecting the required columns: event date, sensor ID, location ID, pollutant name, value, previous value, daily change, and then the moving average 7-day, and then latitude and longitude. Those are the columns I'm going to store in the final fact table, which is fact sensor calc table. So once you execute the script, so this code is commented. So as I mentioned, so for your first one-off load, you can comment this and then you can load it if you have multiple, more than 1 days of data. But when we try and automate this using pipeline, you need to enable this code line to make sure you run the script only for the incremental data that is coming in on daily basis. So that's the idea. Okay, I'll also show you how you can put the script inside a pipeline, the KQL script inside a pipeline, and then automate the process. Okay, so that we will talk about the automation in another video quickly. Okay, and if I come back to the KQL database and then quickly look at the table that we have loaded, fact sensor calc. Let me expand this. So you can filter by, the pollutant type, so that you can verify if the previous value, daily change, and moving average is correctly calculated, right? So let us take one pollutant type. Probably PM₂.₅ is a good candidate to look at. So you can see the data started coming in on daily basis from 12th of August, and then today it's 22nd at the time of recording, 21st, and today's data is yet to come in, but we have data until yesterday for every pollutant that you can see from 12th till 21st. So let us look at the PM₂.₅ pollutant type. From 12th we have started recording the data, and you can see the previous value is correctly calculated, right? So you can see the data is correctly captured. The previous value function is correctly working and then capturing the previous day data and then storing it accordingly, right? That you can see until 21st. And if you look at the daily change, that is also correctly calculated or not, you can have a quick look at it. So it is 11, 9.5, which is negative 1.5, yeah, and I think 6.9, positive 4.1. I think, yeah, daily change is also captured correctly. So our implementation worked really well, I would say. And then the moving average, you see, and the initial data started coming in from 12th, as you see, and then the moving average 7-day, only as per our conditions, it will start calculating the moving average 7-day only when you have 7 days of data coming in, right? So you need to, if you're loading only a couple of days data, you won't be able to calculate this moving average 7-day, right? So you need to have at least 7 days of data for you to be able to calculate the moving average 7-day and then smoothen out. So I think on 18th, the data started coming in from 12th. So, and then you can see the moving average 7-day has been calculated on 18th of August based on the values that you see from 12th here, and then the average is around 8.37. There are some fluctuations that you can see here, 6.9, then it shoots to 11, 9.5, 11.6, and then 4.6 dropped a lot on 18th, but the average is close to 8.3 on at the time of on specific date, which is 18th of August. Then I think it dropped to a bit. You can see it started dropping. The moving average is now smoothened out. As you can see, the value dropped on 19th and 20th to 3.5 and 3.2 for this particular pollutant type, particulate matter 2.5. And you can see the average is also dropping significantly, that you can see on until yesterday, that you can see, and then again it started going up yesterday 7.1, but the average is kind of smoothen out. So the moving average 7-day window is I think it's working perfectly all right. Okay, so you can also have a look at the other pollutant type, and if it's working fine, even you can look at the PM₁, that you can see the daily average, and I think you might Google out and check what are the good target levels for these pollutant types, and then you can derive some insights when you generate some reports. But the idea is, yes, we are able to derive these measures and then compute and then pre-compute and then store it in a table, the previous value, daily change, and moving average 7-day. And it is also possible for you to calculate these measures using the DAX experience in your Power BI data model. That is also possible, but there are some pros and cons. Probably in my previous course I talked in detail about the pros and cons of these two techniques, right? So maybe it's a good opportunity for you to learn more about it by watching that video. So probably I'll link you to that particular video that will help you to understand what are the benefits of pre-computing, and then what are the benefits of or cons of calculating these measures on the fly, you can say. Okay, so with that, I think we have loaded our fact table, final fact table, a fact sensor calc table, and the data got loaded, and then now we are ready to move ahead with our dimensional model, semantic modeling, with the fact table and dimensions that we have at the moment in the KQL database. So I think in the next video we will start looking at how you can build your semantic model, how you can connect your Power BI desktop tool to the KQL database, and then how you can build your data model, establish the required relationships between your fact and dimensions, and then publish your semantic model and reports to the Power BI servers within Fabric. Okay, so that's what we are going to look at in the last module, I would say, and then we are good to generate some nice visuals and then dashboard for you to derive some patterns out of it, and then we will wrap up the course. Okay, so I'll see you in the next one. Thank you. Okay, hi and welcome back. So in this video, we'll quickly look at the dimension setup, right? So before we move on with the semantic modeling, so you should have at this moment the bronze and then silver table, and then you have loaded your fact daily and then calc table. So we also looked at how we can load the metadata from OpenAQ APIs into DIM location. That is also ready. DIM pollutant, I would say that's probably, I'm not going to show you, but if you want to leverage a few more API metadata, you can bring in those and then leverage further. Okay, but what I'm going to show you is you can leverage shortcuts. If you already have some reusable dimensions that you can bring into this solution, you can definitely do that with the help of shortcut capability. So it's just going to be the reference probably you are making here to another workspace, and then bring that particular dimension if you're already having that dimension somewhere in your solution in another workspace within OneLake. Okay, so I already have dim date in my COVID solution in another project, so I'm going to bring that in within the solution so that I can reuse this dimension for my semantic modeling. So that's the idea. And how do you do that? Under shortcuts in KQL database, you can click on new shortcuts, and you can see you can bring in not only from internal sources from your OneLake, you can also connect to different external sources, and then like GCP, Amazon S3, and from your data lake Gen 2 you can bring the data very well in, and then establish that connection. So the underlying data is still going to be residing in the underlying source, so we are not copying data, it's just the reference we are making to the underlying source. So if I click on OneLake, and I can connect to my COVID lakehouse or other sources within my OneLake, and then I can definitely choose to bring in the dimensions that I require. So from my COVID solution, I already have this dim date, so that's what I connected to this, and then created the connection to that workspace. And you can see the icon is a bit different compared to other KQL tables that you are seeing. Okay, and then I brought in as well. I think in another opportunity I'll produce a separate video on materialized views, but at this point in time, for the scope of this course, we're not going to cover the materialized views, I would say. Okay, but we can definitely leverage in another opportunity. Okay, so I think with that I'll wrap up this video on how we can set up the dimensions required for your semantic modeling, and in the next video we are going to quickly look at how we can connect Power BI desktop, how we can connect to the Eventhouse KQL database, and then bring in the required tables for your data modeling. So we will I'll see you in the next one. Thank you. Hi and welcome back. So now we have the required fact tables and dimension tables loaded, and we are ready to build our semantic model. So at this point I think what you can do is you can go ahead and create your Power BI report from within this experience. So if you don't want to move out of the Fabric experience, before you even create Power BI report, you need to build your semantic model, right? So what we are going to do is we are going to navigate to Power BI desktop, and then we are going to make the connection to the KQL database and then build our semantic model there, establish the required relationships between fact and dimension tables. And then we are going to, you can also build your reports there, and then you can publish your semantic model and reports into the workspace here. So that's one way you can do it, and it will be easy. If you already have Power BI desktop, you can make the connection to the cloud KQL database. I'm going to show you that now, how you can do that and build your semantic model and then build your reports and dashboards. If you're already familiar with Power BI desktop, it is quite easier to use that tool, make the connection, and then build your semantic model. So that's exactly what we're going to look at in this video. So since I'm using Mac, I cannot install Power BI desktop within the Mac OS. So what I have done is, in my Azure portal, so I've created I do have Fabric Labs, and then my virtual machine. So I'm going to connect to that virtual machine, the lab machine, and then I'm going to show you from within the virtual machine itself. Okay, and I think if you're someone struggling to set up your own Fabric environment, so in my academy we are providing Fabric lab experience, sandbox kind of experience to you as well. So we can create or spin up a dedicated virtual machine for you to go ahead and practice what you are learning throughout this course. So please feel free to reach out if you need a sandbox or lab setup for us to spin up a dedicated VM for you to practice alongside when you learn. So we strongly believe in bridging the gap between theory and practice, and that's our mission, to bridge the gap between theory and practice. So if you're someone really curious and keen to practice alongside when you learn these technologies, so you can reach out to us if you don't want to take up those setup headache. So we can spin up a new virtual machine for you, and then we will also let you know the pricing. So we have a dedicated membership tier, elite tier, in our DWN Academy. So you can definitely check that out. We will provide the link in the description. You can check out, and if you want to enroll in the elite membership, you will get the complete lifetime course access, and then we will spin up a new virtual machine for you. And we have some restrictions on how we can use the virtual machine on a daily basis. It is like 3 hours per day, because it will be built accordingly, right? So we need to put a cap on how we can use, but we can agree on the time slots in a particular day when you want to use it in that 3-hour window. But it will be a 3-hour window that you can use, but we can agree on the time window, and then you can use it accordingly, and then get the required practice, I would say. Okay, so let us move on to the virtual machine, so that we already have here. So let me expand it. So I'm inside my virtual machine, and I have the Power BI desktop already installed. So if you're so let me show you, give me a moment. Let me minimize this. So I think if you're opening as a fresh blank report in Power BI desktop, you need to bring in your data. So you can make a connection, click on get data, and then you can connect to click on more, and that will take you to all the data sources that you can establish connection, right? So you have a dedicated section that you can see under get data, which is Microsoft Fabric, and you can see you can connect to your semantic models. If you have already built it within the Fabric, you can connect to the Power BI servers, make a live connection. You can connect to data flows, warehouses, lake houses, and there you can see the KQL database as well. So for our real-time use case, we have built the KQL database, and then we have loaded our dimension tables and fact table. You can make a connection to KQL database inside Fabric, click on connect, and that if you've already established connection. So since I already logged in using the same tenant into my Power BI desktop, so you can first log in to Power BI desktop with the same account that you have activated your Fabric trial, and then when you click on connect, it will take you to all the kind of event houses you have within your OneLake catalog, right? So the event house what we are interested in is OpenAQ event house, and then you can click on connect, and it will try to establish the connection to the Custo DB, and then you're connected. So there you can see it fetched all the required tables for me, and then you can go ahead and choose the required tables for you to build your semantic model. So you can select dim location, dim date. Dim date is a shortcut that you can see. It's an external table that I can bring in into my semantic model. And then the fact sensor calc is going to be my final fact table, which I'm going to build the semantic model. So once you load it, then you're good to go. You can start building your semantic model. Let me close this. I'm closing this and then going to show you what I have already done. Okay, so this, okay, so here you can see I already brought in, you can look at the table view and the model view. If I move on to model view, so you can see what are the tables that I brought in from my event house, the dim location, dim pollutant clean that I brought in. But I think probably you can get rid of it for now, you know, since as I already mentioned, you have the required information already in dim location, so there is no need to bring in the dim pollutant clean. But as I already mentioned, apart from these dimensions, you can also leverage different API resources inside OpenAQ and then bring in the required dimensions. So it is not necessarily you need to follow what I'm showing here. Bring in a lot of dimensions from the OpenAQ API and then try and explore as much as you can, and then probably extend the semantic model as much as you can. Okay, so I'm to keep things simple, I'm keeping it very simple with a couple of dimensions and then the fact table, but please leverage and explore the other resource APIs that you can bring in for metadata. Okay, so location, then the external table, if you remember, we brought in shortcut dim date that we are bringing in, and then the fact sensor calc. That's it. Okay, and you can clearly see I'm making this as import storage mode. Okay, so when you're trying to kind of build your semantic model, it will ask for the storage mode. So whether you want to copy, make it as import mode to bring your data into the memory. Otherwise, if you want to make a direct connection, you can use direct query, or I think from Power BI desktop we don't have that option to enable direct link. Maybe I think we can explore that, but if you're building your semantic model right within the kind of Fabric experience, you will have that option. I think if the direct link capability will be there when you're trying to establish your connection to the lake house, right? So here in this case we are looking at event house. So I think there are some restrictions around, because at the time of building my semantic model, I got only a couple of options to go for. One is import mode, storage mode, and that you can see clearly the icon next to each and every table, it is of import storage mode. Otherwise, you can go to direct query, which may be a bit slower if you have a complex semantic model, right? But I think our underlying data source is event house for our real-time use case. Probably that could be the reason we are not able to build our direct lake semantic model, right? So in case of if the underlying source is lake house or data warehouse, probably you might be able to build your semantic model with direct lake storage mode. So, and if you're new to direct lake storage mode, probably I have already produced quite a lot of videos. I have a dedicated one lake series playlist in my channel. You can go through that, and I talked in detail about the 3 different storage modes and the groundbreaking technology that Microsoft introduced in Fabric, which is direct lake mode, which is quite faster than direct query. I'm not going to get into the details of those. There is already a video out there in my channel. You can go through it, and if you have any questions on the 3 different storage modes, you can reach out to me. But I think from core scope, we are going to stick to import mode since we are building our semantic model right within Power BI desktop, and we are making that connection to event house KQL database, and then we are choosing the storage mode as import mode, which essentially copies the data into memory. And also when you work on the data model within Power BI desktop, it copies the data locally here as well. Okay, and then I think you can start building your relationships, right? So between your fact and dimension tables. So only a couple of dimensions we have. So here I established connection between the fact sensor calc and the location dimension on the basis of sensor ID that you can see here. The relationship will be one to many from fact to dimension. From dimension to fact table. Okay, so usually from fact to dimension table, it should always be the cardinality should be many to one. Okay, so that's how we are designing the data model. So I hope you're very much aware about the different cardinalities that you can set. Okay, so but in a typical star schema dimensional model that we're building here with your fact and dimension tables around, it will be always many to one connection that you need to establish between your fact and dimension table. Okay, and you can go ahead and make that relationship active, and then we also make establish the connection between the fact and the dim date table on the basis of event date on the fact table, and then you can see the date key on the shortcut dim date table that we brought in from another COVID lake house. Okay, so those are the couple of connections, and then if you want to leverage the dim pollutant, but I think for now I'm going to disable this or probably delete this. I'm not interested in dim pollutant at the moment, so even I can kind of delete this from my model. So only I have couple of connections, as you can see here, and then I'm ready. Okay, so we can start building some reports, and then we can slice based on the sensor information and then the date information, and you can derive some insights based on for every pollutant type as well. Okay, so we're keeping things really simple, but I hope you got the idea, and then you can probably extend your data model as much as you can with different dimensions. Okay, but once you have it ready, you can always go ahead and start building your reports here. Okay, so we are going to look at the different reports that we are building here, and then how we can publish your reports and semantic model into the KQL database, not inside the KQL database, into the workspace within your Fabric environment. Okay, so that is also possible. So you can save your changes and then start publishing your okay, so it is asking when to publish to Power BI service. It will ask the destination, so it's showing up all the workspace that I have. So the air quality real-time analytics workspace, you can choose and then push your semantic model, and then the reports and dashboards as well. So it's as easy to quickly deploy your changes, okay, the model as well as the report dashboard changes. So let us quickly run through some of the visuals. So if I come back to Fabric real quickly, so I've already published the semantic model. So once you publish the semantic model, after you establish the relationships, you can see it should appear here. You can name it as you want, air quality real-time analytics, and you can see the semantic model is published already. And I think you can also have a look at the semantic model right within Fabric also, okay, within the Fabric experience. So you can click on open semantic model. Okay, you can see the at the time of publishing, I also brought in dim pollutant clean and all, but I think it's not probably required. If you want, you can bring in. Okay, but if you open the semantic model, okay, so the last published semantic model from Power BI desktop into the Power BI service within this workspace, you can clearly see. You can also look at the different tables, dimension tables and fact table here, and the relationships. Okay, so yeah, I think where I last published, I also brought in dim pollutant clean, but I'm not using it in my report. So as I mentioned, you can make this model as complex as possible by bringing in a lot of metadata dimensional table that you can build and then establish the relationship. And you can also build more measures if you want, and then extend this data model as much as you can. Okay, but we are viewing it in view mode. You can also go into edit mode. If you click on edit on the top right, switch it to edit, you can always edit the model right within the Fabric experience also. You can see the model view is there, DAX query view is there, right? So you can have a look at it. And I think inside the model view, again, from within the Fabric experience also, you can see the storage mode when it was last refreshed as well. Okay, great. So I think in the next video, we will quickly look at how you can design some reports based on the data model that we have just completed, the semantic model, and then we will look at few visuals that you can build, and then you can feel free to build your own reports and dashboards as well. Okay, but with that, I think we will move on to the next video where we will look at a few report designs, and then we will probably move on to dashboard and then the automation part as well. Okay, thank you. Hi and welcome back. So now we have our data model ready. Okay, so let us move on to the Power BI desktop within my virtual machine. So probably if you have Windows machine, you can quickly navigate to Power BI desktop and quickly look at some of the visuals that you can generate, right? So, but feel free to kind of explore a lot of visuals with the kind of data model that you are building. Okay, but I'm just giving you a head start so that it will be easy for you to think about some of the visuals that you can generate out of this data, okay, for this real-time use case. Okay, so great. So I think you can come up with a summary, okay, summary table, like you can bring in the date key that you can see, and then the location information, country, display, different display names gives you the different pollutant types, and then the value and the units, and then the daily change and moving average. So you can always sort it by display name. So you can see I think the PM₂.₅. So I think you can have a look at it. So I think instead of having a look at it here, so maybe you can generate the reports in your inside your Fabric also once you push your semantic model, or you can very well design your reports and dashboards here and then publish it to your Power BI service also. So either way you can do it. It works really well, so not a problem. But let me quickly show you. So however you want to do it, you can do it, but I'm going to show you maybe here the reports are outdated. But these are some of the types. You can build a summary table to look at different pollutant types for a particular location, and then the daily change, and then the moving average. But you're not seeing any moving average data here. Maybe it's probably this visual is not refreshed here. That's why I'm going to go back to the Fabric experience and then show you there. Okay, let me navigate to the Fabric portal real quickly, and let me bring up the reports. If I go to workspace and I have the report, air quality analytics report. So let us look at different reports that we can generate. Okay, so the air quality summary that you can see here. Okay, so probably this visual, we can try and refresh it once. Yeah, okay, so great. Okay, I guess the model is not refreshed. I'm not seeing the moving average calculated. So let me do one thing. So I think there were some bugs which I had to fix it. Let me refresh the semantic model as of now. Okay, so and then we can track we are going to automate the refresh. No manual intervention is required. In the next video, once we are done with the visuals and dashboard, we'll quickly look at how we can automate the pipeline end to end. Okay, so I'm going to show you that as well. So version history, I think it's done. I guess we can always look at the refresh history, and on demand it's refreshed, completed. Okay, so now let me open the report and then reload the report and see if it's refreshed. Yeah, great. So there you can see now the data is coming in now. So I think let's take the PM₂.₅ instance. Maybe let me put this in focus mode. How do I put this in focus mode? Yeah, so yeah, now it is, I think, a bit okay, right? So I can zoom in. So take one example, like probably PM₂.₅ pollutant in Del Norte, United States location. The data started coming in from 12th, as you can see here, and then until yesterday I have the data loaded for this particular pollutant. If we take any pollutant type, we have the data from 12th till 21st. On daily basis it got automatically loaded. So every day you can see the value and the units, and then the daily change from previous day that got recorded correctly. And I think once you have 7 days of data, I can see from 12th, I think 18th, it started calculating the moving average for the last 7 days, right? And that will kind of smoothen out any major fluctuations. You can see it went up to 11, then dropped to 4.6, 3.5, 3.2, but it nicely smoothen out the fluctuations or any noise in data to look at a standard kind of a stable or reliable value that you can look at in with the moving average 7 day. And that's the idea, that we're calculating moving average 7 day, and then once the the model refreshes today, I will get the 20-second data, and then the daily change and moving average will be calculated. So you can have a visual like this if you want to look at different pollutant across the locations and the moving average. That's one kind of a report that you can generate. And then let's look at few other reports that you can probably look at. So you can also look at average air quality index across locations. That's one thing you can do. So what I'm doing here is, let me put this in focus mode again. If I just, okay, I think it's already in focus mode. Okay, good. Okay, so all I'm doing is I'm looking at average of the air quality index, the value, and you can see the display name is nothing but the pollutant name. So you can see what are all the things that I'm bringing in. If I click on edit, so you can see from dim location I brought in the display name in x-axis and location name as a legend that you can see. Okay, and from my fact table, fact sensor calc table, I brought in the actual sensor value, and then I average, and I'm giving the aggregation as average of value in my y-axis. That's what I'm doing here. If I can put it in focus mode again, how do I put it in focus mode? Reading view. Yeah, okay. So here I think for PM₁ for that location, what is the average value, which is 21.20 in the last 10 or 12 days, and then PM₂.₅, the average value is around 7.24. I think it's a very good air quality index for that particular location, because I'm going to show you some gauge visuals as well that will help you to understand the target, the good target, right? So it is around 12. So if it's 12 or lesser, the air quality is very, very good, very good to breathe. And if it's crossing 12, maybe we need to be watchful. And I think there are some limits, okay, so that you can just Google out. Some standards are there for every pollutant, so that you can easily Google out and understand the target levels, okay. And you can track the average across all the pollutant types for that particular location. And if you're bringing in data from multiple locations, you can always have a look at that legend and try and infer probably the neighboring location. You can bring in the data from neighboring location from New Mexico, and then you can always compare the average between those two locations for different pollutants. So that's one kind of report that you can generate as well, okay. And let us look at a couple of gauge visual. I have this nice gauge visual that I'm generating for PM₂.₅, which is very harmful if you're breaching a particular limit. Okay, so they say 2.5 micrometers in diameter. So you can read more about it. So that is some minute particles that will you may probably inhale, and then that will be harmful. Okay, so if you can just Google out, I think as per my investigation, the PM₂.₅ target is around 12, which is good limit. If you are within that limit, well and good. Our average is around 7.24, which is good. And I think the max hazardous limit is around 500. If you're breaching that, it is even, I think it's halfway around, is also not good for health. It's harmful, but the maximum hazardous limit is around 500 is what the standards I can see in Google, okay. There are some organizations across the world, they are setting this air quality index levels for every pollutant type, so you can go through that, but I'm not going to drill through that details now. But you got the idea, right? So from this gauge visual, I get a clear view of what the good target level is and what the current average is for this particular pollutant, and like that you can put a gauge visual for all the different pollutants. For PM₁, the good target is around 54, and the current level is well within that limit, which is 21.20. The maximum hazardous limit is around 604. Okay, so you can put a kind of a gauge visual. So how you want to generate, let me quickly show you for this sample. We can bring in a gauge visual, as you can see here, and the required values is like, I'm going to bring in only the value, right? So the value, and then I created some measures, the DAX measures for max limit and min limit for PM₁ and PM₂.₅. So I think to have a look at that, let me go back to Semantic Modeling. I think it's very simple. I'm just hard coding those by looking at the standards. So if I can just scroll, so I can show you for PM₂.₅ max. me switch it to edit mode. So you can see I'm hard coding PM₂ max measure as 500, then minimum will be 0, and then target is around 12. That is helpful for me to set up some measures so that I can bring in my gauge visual. So only for the purposes of gauge visual, I put those hard coded measures there. If I edit this report, you can see I brought in those PM10 related hard coded measures, okay, the min, max and target, and I'm just mapping those measures in there, okay, the max, min and target, and then the actual value is the average of PM₂.₅, okay, so that we are bringing the value, and then we are aggregation is set as average. That will give you this nice visual, gauge kind of visual that will have maximum target, maximum level, the target level, and then the minimum, and then the actual average. So that will help you to have a dashboard and then look at this view. That will be helpful to understand if you're breaching the good target, or if you're breaching the maximum target, or maximum hazardous level, or something like that. So that's the idea, okay. And coming back to, okay, let me put this in reading view, and I think you can also build map visual, something like this. I think it's really nice to have a map visuals, because you know, as I told you before, you have the latitude and longitude information, so that's more than enough to build a map visual, okay, in a map. So how do we do that? You know, let me click on edit and show you. So I think we don't have a ready-made, I think we do have some map visuals inbuilt, but you can always, you know, click on get more visuals by clicking this 3 dots, and then you can bring in some new visuals also. So the one that I have here is what is that? Map by Squillion, okay, that you can see here. So you can go to get more visuals, and you can search for map visuals, right? So you will get a lot of visuals if you click on map. And I think I brought in the one from Squillion, okay. There are a lot out there, you can choose whatever you want, but the one that I brought in is by Squillion, which is this, and then I brought in my legend as well, which is my pollutant. So I have this slicer. So when I switch the pollutant type, I can clearly look at the average information. So what other information we are keeping here? Let us quickly go through that. So if I click on this visual, okay, just a moment. I think I need to, don't save. I click on edit. Okay, now I can see. Okay, so you have to select this map visual and see what are the configurations that you have done. So we have brought in, so you can see from location dimension, I brought in the display name, okay, and then the latitude and longitude information, and then the location name, okay. So how did we place it in the visual? The average of value and latitude and longitude information, I copied it. I mean, I brought in the required data for latitude and longitude, and pollutant type is a legend, or the slicer that we have, okay. So within that, so you can see here, yeah, so I think, okay, sorry, I think for the map visual, this is where you have, and this is filters that we have applied here, okay. So here, I think for the map, you can see the location name is brought in, and then the marker latitude and marker longitude, I brought in the latitude and longitude from dim location, and then the marker value is going to be the average of my value from fact table, okay. And that will help you to have a visual something like this. So as I mentioned, if I go to the reading view, so you'll have a nice visual like this, you know, in the map, and you can see it is plotted nicely based on the, so if I can, based on the latitude and longitude information we provided. It is in the New Mexico in United States region, and you can see the pollutant type is chosen as PM10, and the average value is around 21.2, and I can switch in the slicer to PM₂.₅, and I can see the value for PM₂.₅ pollutant type, what is the average value, which is around 7.2 for this particular location. So you can build this kind of a nice map visual, and then you can move it to your dashboard so that you will have a nice view, and then you can clearly monitor and track your different pollutant types and then the levels, average values across the location. Okay, I'm just giving you a head start. You can build some nice visuals like this. Okay, but if I quickly go on to dashboard, so I brought in some of these visuals into my dashboard. So that's how I built my dashboard. So you can see I brought in my map visual and the refresh time is available there. And as I mentioned, you can always switch between different pollutant types. Well, let me enlarge this. You can switch between different pollutant types and then you can track the pollutant type and then the average value of it. Okay, so there you can see the kind of a pin icon that's having in a blue pin. And if you are bringing in multiple locations, if you're building the solution for multiple locations, you can cleanly, nicely switch between different pollutant types and track the average value across the locations. Okay, and across the world. Okay, that is totally possible. Okay, and as I mentioned, we talked about the gauge visuals. As you can see, it's nicely fit in here. For PM₂.₅ and PM₁, I can see the good target levels and the current average and the maximum hazardous levels. But you feel free to bring in other pollutants also and then build the gauge visual so that you can stack those around here in dashboard and then have a look at a nice dashboard kind of a view, right? So you can build that. And you have this average bar chart to look at different pollutant types for this particular location. And if you have multiple locations, you should be able to see different bars and then you can compare the bars. Okay, so that's just a head start for you to show you what are the capabilities you have, or what are the different kinds of visuals that you can produce for this kind of a real-time air quality analytics use case, right? But there are always opportunities for you to build more visuals and then build your nice dashboard kind of a view for this kind of a air quality real-time analytics use case, and it will be really helpful to monitor different pollutants across locations and then look at the average values of those. And you can also have these kind of a nice gauge visuals to track the target levels and what is the current average level and where we stand for different locations also. Okay, right now it is for one single location. Maybe for this gauge visual you can bring in multiple locations and then probably you can have different color codes to track your pollutant types, okay, across different locations. Okay, so with that we will close this video, and in the next video we will talk about how you can automate this entire solution end-to-end with data pipelines, setups, and scheduling the scripts, KQL scripts and all, and then we will wrap up the course. Okay, so I hope this session is useful and I'll see you in the next one. Thank you. And welcome back. So I think we are done with the reports and dashboarding. So there are always opportunities to come up with more reports and dashboards. I'll leave that to you as your assignment. You can build your own nice dashboards and then you can comment in the comment section, or you can share it with your with the community. So we'll really appreciate that. But now let us quickly look at, let us come back to the workspace and let us quickly look at how you can automate this end-to-end. Okay, so I think at the time of ingestion into Eventstream, so we were using a couple of few notebooks, if you remember, to bring in the sensor data and then the metadata, right? So you can always go ahead and schedule that scripts right away. So those are PySpark scripts. So if you can get to the schedule by right clicking the three dots, you can add a schedule, okay, and then you can schedule it. Okay, so you can see the last successful refresh and then you can schedule your refresh. Okay, so I think for the metadata notebook, you no need to schedule the notebook. As I already mentioned, it is going to be a one-time load. So only for sensor data that you're going to bring in every day, you need to schedule your notebook. Otherwise, this notebook, you no need to schedule your metadata notebook. Okay, let us look at the schedule for the sensor data. So you can go ahead and schedule and you can see I have scheduled it every day at morning 11. Okay, so you can just schedule the notebook directly. Okay, and you can always monitor the runs as well. There are, when you go to recent runs, you can see the last runs. Okay, you can see it is running on daily basis, and you can see it is all success that you can see here. Okay, it ran for a few seconds. Okay, close to 50 seconds, 46 seconds, and then it got executed successfully. You can always monitor the runs as well from within this workspace. Okay, and I think we have built few pipelines to automate the KQL scripts. Okay, so if you remember, for our silver transformation we have used KQL scripts, and then for fact daily load, fact daily calc load, sensor fact daily calc load, we have used KQL scripts. So I built a few pipelines to attach those SQL scripts and then automate the pipeline. Okay, so let me quickly show you the silver one. You can create go ahead and create a new pipeline, data pipeline. Okay, so there you go, and then I'll show you how you can attach the KQL script and then automate it, okay, or schedule it. So there are many activities that you can bring in inside your data pipeline, and I think all we are interested in is if you just scroll down at the bottom, you can see under transform you can use the KQL, okay, KQL script. Okay, choose KQL, and then in the settings you can provide the command directly. Okay, so there you can see. So we already had a look at this. We gone through line by line the transformation code. The same script you are going to copy, but make sure when you need this script to run on incremental basis, you need to enable that. Make sure you enable that code where we have a var clause to fetch only the data, only the day's data, right? So only the latest day data. Okay, so tomorrow when we run this at 11 or 12, I need to bring in only today's data. Okay, and you also need to make sure the timings are right? So the notebook execution, the sensor sensor data that we're fetching from API should be scheduled first, probably at 9 o'clock in the morning, and then once we get the data into our raw table, then you can schedule this pipeline where we transform and load it to silver table from raw table. So I hope you understand, right? So you have to manage that time and then schedule it in order, right? So in a sequential order. Okay, and I think once you have the script, you need to make a connection to your Eventhouse, and then you need to provide a command. That's it. Okay, and then all you need to do is schedule that pipeline, which is del not a silver. I think scheduling is quite simple. You have to go to schedule and then schedule it. Okay, you can see I have already scheduled it every day at 11:30. The notebook execution will run at 11 in the morning, and the silver transformation script will run at around 11:30 every day. Okay, and moving on, the same thing we have done for fact daily calc. So we have created a pipeline connected to the Eventhouse, and then we provided the KQL command what we executed at the time of loading. So with the for the incremental ingestion, we have enabled that var clause to bring in only the latest day's data. Okay, and then you have to schedule these as well accordingly. So it will go in order: silver first, then the fact daily will be loaded on daily basis, and then the fact sensor daily calc will be loaded from daily. Okay, so it has to be in that order for you to load that final fact table for our reports to be refreshed on daily basis. Okay, so that's it. I think apart from that, you also need to make sure you set a schedule for your semantic model as well. Okay, so you have to make sure if you go to settings in your semantic model, you can see here, if you just scroll down, you can see under refresh, you have to choose the time zone and then enable the refresh schedule on daily, and you need to make sure the semantic model refresh will be at the end after the data is loaded into the fact table. Okay, so the metadata is a one-time load. It is already done. So once your data pipeline runs and then loads the final fact table, then you need to make sure you enable the semantic model refresh on daily basis. So I have it at around 2 o'clock in the noon, 2 p.m. So it will be executed successfully. Okay, so you can also have a look at the execution history or the monitoring aspect, right? So for the semantic model as well, so if I can go to the refresh history, you can see whether I executed it on demand or schedule. So today we executed it on demand, to look at the data since it was not reflecting fine. But I think on daily basis it's executed. As you can see, on daily basis it is getting refreshed automatically. Okay, Well, I think that's it. I think once you're done with this automation part, I think you have a fully functioning end-to-end pipeline to monitor air quality index for any location in the world. Right now, for this demonstration, we looked at one particular location, and then we automated the entire process right from data ingestion till the dashboarding. Every morning when I come in, the pipeline runs automatically, and once the data model is refreshed, I should be able to see track the air quality data for that particular location in real time. Okay. I hope this session is useful and this course is useful, and I think in the next video we will look at the key learnings we had in this course, and then we'll wrap up the course. Thank you for watching. Welcome back. So I think we now have a fully functional air quality real-time analytics solution that we built end-to-end and automated as well, and you can come up with nice dashboards, and then you can track it in real time every day. Okay, for any location in the world, from OpenAQ API you can bring in. And I think let us probably look at the key learnings that we had in this course. So we looked at a real-time use case to track the air quality index, you can see, across any location in the world. And for demonstration purposes, we brought in this Del Norte location, which is in New Mexico, United States, and we looked at a couple of APIs to bring in the latest sensor data for that particular location. And then we also looked at one more API, location API, to bring in the metadata for location and sensor, and then we loaded it into our dim location dimension, right? And then I think we automated the scripts to, we had Eventstream gateway to do the real-time streaming ingestion into my bronze table in my Eventhouse KQL database. And then we did some transformation and loaded into silver layer in our medallion architectural pattern. So we followed medallion architectural pattern here. And then once the silver table is loaded, we moved the data to our fact table by performing the required joins. And then we had to calculate some measures and then load it into the final fact calc table. So we calculated, we pre-computed, let's say, the previous value, and then the daily change, and then the moving average 7-day window calculation to smoothen out the fluctuations, if any, or noise in the data. And then we built our semantic model. We made a connection from Power BI Desktop to the KQL database, and then we built our semantic model, established the relationship between fact and dimensions, and then we built our reports and dashboards finally. Okay, we had some nice dashboards we looked at, like the map visual, gauge visual, but I think you can be creative to come up with a lot of visuals and dashboards to track the air quality index across locations in the world. So those are the key learnings that we had in this particular course. And if you think about real world applications for this particular real-time analytics solution for air quality that we built, so you can plan, urban planning can be done, and I know probably we can do health impact analysis, because it's quite crucial if the pollutant, you can keep a close eye on the pollutant types and then the target levels, like I've shown you in the gauge visual. You can keep it a track, and then you can do some study on the health impact, probably across regions in the world. The one location that we looked at in US, it's having a very good air quality, as we have seen. It is well within the good target levels. Probably you can choose some vulnerable cities in the world, like Delhi in India, and locations like that will help you to understand what is the kind of air quality index that we are looking at, and whether we are breaching that target level, and where the level stands at the moment. And you will then come to know how harmful it is for people out there who are breathing that air, and then it will pose a lot of serious health concerns, right? So you can do that health impact analysis once you have your dashboard built for any particular location, right? So that's the real world application for this particular solution that we had built. Okay, and also environmental policy simulation. If government is coming up with any environmental policy that they wanted to simulate, they can have this dashboard built, the customized dashboards built for probably few locations that they are interested in, the vulnerable cities, as I mentioned, but not for all the locations. Maybe for India, Delhi, and then probably across the world there are some vulnerable cities, that's probably breaching the air quality hazardous limit. So probably government can look at that and then come up with some environmental policies as well. Okay. And then the citizen air quality alerts. You can also probably leverage the data activator capability in Fabric that we will probably look at another opportunity, and probably create some alerts if it's breaching some limit for any particular location, and then probably citizens will get air quality alerts, and then probably they may be probably be aware of what the level is, and then they can take some precautions to avoid going out and then stay indoors and things like that to prevent any harm to their health as well, right? So those are different real world applications that you can leverage this air quality real-time analytics solutions we built end to end for urban planning, health impact analysis, environmental policy simulation, to name a few, and then citizen air quality alerts. Okay, let's talk about what's next. There are a lot of opportunities for you to extend the solution further. So you can add weather integration, then air quality index forecasting using machine learning. That's another use case. Or when you have your solution built and the dashboard built, you can publish open source version of it for people to download and then look at your dashboards and then track the air quality index. Okay. Those are some of the opportunities and a lot of opportunities out there to extend the solution further for different use cases. Okay, well, so I think with that we are wrapping up this course, and I hope this course is really useful and you can apply this and also you can extend the solution, as I mentioned, with different capabilities further. So that will really be helpful to the community, okay, for the larger goodness, you can say, and for the planet goodness as well. So it's always good to keep a track of the air quality index out there wherever you are across the world, and the kind of air quality index awareness is very critical probably at this moment. So it will be really helpful if you can build such a nice dashboard and keeping a track of what's going on around the world and how harmful it is when you're breathing something outside, right? So the air quality index matters a lot. Okay, so, and I'm going to publish this courses out there on YouTube. You can watch it for free, and in case if you need the downloadable resources and if you need my dedicated one-on-one coaching, feel free to enroll in Data Beyond memberships. So you'll find the links in the description. You can go through it. And if you want to implement, if you're a business, if you want to implement real-time analytics solution like this, partner with us. We can be reached. We'll provide the required contact information in the description. You can reach out to us if you want us to help you and partner with you for building such real-time analytics solutions for your business. Okay. And feel free to comment if you have any questions in the comment section below, and we will be glad to look at it and answer those. Okay. And as I mentioned, you can enroll in the full course on Teachable platform. If you need full access, you can join us. And there are other learning tracks. As I mentioned, you have membership options, or if you need to purchase, do a one-time purchase on the courses, that is also available on the Teachable platform. You will find the Teachable course enrollment link in the description. Feel free to have a look at it, and then it will also be pinned in the comment, so you can have a look at it and then enroll in the course if you want to enroll in full course. Okay, or if you need my dedicated support as well. Okay, thank you for watching. I think we are ending this course on a good note, and join us in building a greener world. So I think this use case, real-time use case, is quite critical at this point in time, and that's the reason I wanted to build such a kind of real-time analytics solution to track the air quality index. So join us in building a greener world. So come up with your own reports and dashboards, and I'm really curious to see how creative you are to come up with nice dashboards to track air quality index different pollutant types across the locations in the world. Okay, so thank you so much for watching, and I hope you enjoyed this course, and I'll see you in another course. Thank you.